Hello students, welcome to the class. So today is the day 29 of this JEE 40 days crash course and we will be doing a new chapter which is hydrocarbon on the 29th day. So this is our disclaimer. In today's class, we will discuss three types of hydrocarbons. So hydrocarbons are those species which contains only your carbon and hydrogen. We have studied about the classification of your given organic compound into saturated and unsaturated one. So in the saturated one, we have this alkanes where there is only single bond present in the entire compound. Now in that we will first of all study the general methods of preparation for the alkanes and the physical properties of alkane. Then after we'll move on to the reactions that are given by the alkane. It will come under the chemical properties. And lastly, the conformations. So we can say that four things are there: preparation, physical properties, chemical properties, and conformations. In the alkene, we will only focus on the preparation methods, the chemical properties, and similarly for alkynes also we will focus on the preparation method, the chemical properties. Okay. Now in these alkenes and alkynes, the physical properties and the conformation part. So alkanes only are capable of showing conformation because rotation is only allowed across the single bond, and in case of alkenes and alkynes there is presence of multiple bonds which prohibits the rotation, and hence there are no conformers. Talking about the physical properties, so physical properties of all hydrocarbons are quite similar to each other. So if you know about alkanes, you can predict it easily for the alkenes and alkynes. Next, we will study a special type of set of hydrocarbon known as aromatic hydrocarbon. Here, we will study about the aromaticity. How can we consider that the given compound is aromatic in nature? Then after, we'll move on to a very stable aromatic hydrocarbon and the famous one known as benzene. So we will try to understand this aromaticity using a specific example of benzene and how the benzene is stabilized and what are the experimental results that led to the idea of aromatization, starting it from the benzene one. After doing this, we'll move on to again the preparation of benzene and the chemical properties of arenes. Next, so first of all, starting from the general methods of preparation of alkanes. The first method is known as hydrogenation. If you take an unsaturated hydrocarbon, then you can add hydrogen to the same to make it a alkane. Now, this hydrogenation or the addition of hydrogen is done in the presence of catalysts such as platinum, palladium, or nickel. So here is the reaction for the same. First of all, we'll see it for the alkene. It is reacting with hydrogen, or the hydrogen is getting added to this alkene in the presence of platinum or palladium or nickel. So you can use any one of these three catalysts to get your corresponding alkane. So here we started with ethene and we are getting ethane. Next, we can always start with an ethyne also. Suppose we have taken propine here, and for propine we will need two equivalents of hydrogen because there are two multiple bonds. Got it? So to reduce this two bi bonds, we will need two sets of hydrogen molecule. Again, the same catalyst can be used here. It can be platinum, palladium, or nickel to give us the saturated propane. Next, the preparation method is known as from alkyl halides. Now, what are alkyl halides? It's very simple. The hydrocarbon, when attached to a halogen, it is named as alkyl halide. How can we prepare alkane from this alkyl halide? To do that, we will do the reduction. Now, why are we calling it a reduction? Remember the classical definition of reduction. Whenever we are removing an electronegative element from a given compound, it is known as reduction. So here we are removing Cl, which is a strong electronegative compound and replacing with a hydrogen which is comparatively less electronegative. Therefore, we can also name it as reduction. How are we doing it? So basically, we are adding hydrogen in the presence of zinc metal and H plus. Here, zinc H plus is your catalyst part, and upon reaction, it will give you methane. How the reaction would be carried out? So it is basically carried out on the surface of zinc, and the catalyst which is used here is specifically your H plus ion. Next method is from alkyl halides. So we can also use the Wood's reaction to prepare our alkane from the alkyl halide, apart from reduction. So what we do here is a coupling reaction. So Wood's reaction comes under the coupling reaction where we take two different alkyl halides and treat it with the sodium metal. And this thing is done in dry ether. Dry ether is used because sodium is highly reactive in nature. If you try to do the reaction in any other solvent, then it would be exothermic, and it can cause severe burns during the reaction process. So to keep the things in control, we use the sodium metal, and then we are getting higher alkanes. Now, what is the meaning of this higher alkane? If we take a bromomethane, then we will get ethane. So basically, the alkane part of your alkyl halide is getting coupled up to give us the final product. Got it? Now the question comes, what is the drawback of using this Woods reaction? Why can't we stick to this Woods reaction only? The problem is that in case of Woods reaction, it is easier to get a hydrocarbon containing even number of carbons, right? In that case, we can use the same molecule and only one type of product is formed. Sorry for the interruption. What did I say? It can only be used for preparing a hydrocarbon which contains an even number of carbon. Suppose if you want to prepare butane, you can use two molecules of ethane halide, right? So that is ethyl halide. So that is something which is possible and it will always give you a single product. Now suppose I tell you to prepare propane from this, then what are the two components you can take? You can take one as your propyl halide and other as your ethyl halide. Now what is the problem here? The problem here is that you will get your product. So that is for sure your propane part and your ethane part will combine together to give you a pentane part. But the propane will react with itself also to give you the hexane, and similarly your ethane will also react it with similar kind of molecule and give us butane. So you got the point here. So this is the problem. We are not only getting our required product or our target product, we are also getting some side product. And the main problem is that hydrocarbons are quite similar in their chemical properties. So your butane, your pentane, and your hexane, their properties would be closer to each other. As a result of this, the similarity of the physical and chemical properties makes it very difficult to isolate the required product, because we can't separate it through any physical or chemical methods, because this would need distinguishable chemical and physical properties to separate them. But belonging to the same hollow series gives them the same kind of physical and chemical properties. Now, next, here we have reaction for the same. So we have taken methyl bromide and treated it with the sodium in presence of dry ether. So although it is not mentioned here, because it is used as a solvent to do the reaction in a proper medium. What will happen? Two, two of the parts of your alkyl part will just couple together, CH3 and give you the ethane plus the sodium bromide. Next, we can also prepare it from carboxylic acid. So first we started from alkenes, and with the help of hydrogenation of alkenes or alkynes, you will get your alkane. Second is your alkyl halide. In that case, we use your zinc and hydrochloric acid and your Woods reaction. Now comes your carboxylic acid. In this reaction, we take sodium salt of carboxylate ion, and then we treat it with hot soda lime. Soda lime is a general term used for the combination of reagents of calcium oxide and sodium hydroxide. So this together is known as the soda lime. After the reaction, what you will get? You will get your corresponding alkane, and that alkane will have one carbon less than the actual carboxylate acid. Got it? You can see here very clearly that we have started from sodium acetate. But what did we get? Did we get ethane? No, we got methane here. Right? Now one more question. Suppose you are starting from the carboxylic acid itself. Rather than starting it from the sodium salt of carboxylic acid, you are taking CH3COOH. Then what you will do in that case? First you will treat your given acid with a proper base to convert it into the salt. Once you get your salt, then you can further carry out your reaction with hot soda lime to get your corresponding alkane. So this is the precursor method for getting your sodium salt of carboxylic acid. Next method from which your carboxylic acid can be converted to your alkane is your coal-based electrolytic method. The name as suggests. So in this process we do electrolysis. And here also we have a problem of getting even number of carbon atom in the alkane, because coupling is the part that is playing your product formation. So let me give you an example. Again, we have to take the sodium salt of carboxylate ion, and then we have to do the hydrolysis of it in the aqueous solution. What will happen? At the anode part, the oxidation will take place. So your the carbon will be converted to carbon dioxide, which is the most oxidized form of carbon. So first is your normal alkane, then alcohol, then aldehyde or ketone. Next is your carboxylic acid, and the most oxidized form is the carbon dioxide. So we have converted this part of COONA into CO2. What will happen at the cathode? At cathode, we will get the rest of the part. And at anode, we will also get our C2H6, which is our required alkane. So this is the overall process of the electrolysis. Okay. So I hope it is clear to you. So this is also very, very important. You must remember that we will always get an even number of carbon atom at the anode. Here, odd number is not obtained during this electrolytic method. Next, so we have learnt about three methods till now. First, from the alkene, in which we use the hydrogenation, means adding hydrogen to remove the pi bond. Second is our alkyl halide, in which we use two methods. First is zinc and hydrochloric acid, and the next one is your Wood's reaction. After that, we dealt with the carboxylic acid. Again, we have two methods in them. So first of all, you have to convert your carboxylic acid to a carboxylate ion, and that is very simple. You treat your carboxylic acid with the sodium hydroxide. It will give you your corresponding carboxylate. Then after, you can do it through two methods. Either you can treat it with the hot soda lime, which is CaO and NaOH, or else you can do the electrolysis to get your required product. In the case of your decarboxylation, what will happen? You will get your alkane whose carbon count will be one less than the starting one. Suppose you started with acetate ion, you will get methane. So the COO part is converted to the carbon dioxide. What happens in your electrolysis? In your electrolysis, you get even number of carbon always. And how do you calculate the even number of carbon? What will be the count of that carbon? Suppose you started from the acetic acid. So if you add 2 moles of acetic acid, you will get 4 carbons in total. Now remove 2 carbons from them. So whatever product you will get, that will be your required, or sorry, that will be your resultant product. Now suppose you started with the propanoic acid or sodium salt of propanoic acid. Then first of all, you add the carbons of 2 propanoic acids, which will be giving you 6 carbon, and then remove 2 again from it, and that will be your product, means a alkane of 4 carbon. I hope it makes sense to you, because in this whole reaction your CO2 is being removed at the anode part. Now the next one is the Grignard reagent. What happens in the Grignard reagent? What is Grignard reagent? First of all, you should know that also. So Grignard reagent is a compound in which we have a bond between the carbon and the metal. You can see here it is represented as RMgX. So this R is your alkyl group and it is directly connected to the metal. Then upon that we have a halide group attached to the magnesium, because magnesium is a alkaline earth metal, it will always have an oxidation number of +2. So one of that is being satisfied by the alkyl group, and the second one is being satisfied by the halide group. What will happen after that? It will react with H2O or ROH to give the corresponding alkane. So here is your reaction. First of all, we have treated with water. So this Mgr part will be removed and you will get your ethane and your MgOHBr. Okay. Next, the last and the preparation of method. So here are some notable considerations. So if you treat your aluminum carbide or your beryllium carbide with water, it will give you methane. So here is a reaction. So this is your aluminum carbide. It's very simple to remember. What you have to do is to exchange the valency. The valency of carbon is 4, so that will be on gone to the aluminum, and the valency of 3 of aluminium is gone on to the carbon. So Al4C3. Next, just do the hydrolysis of it. It will give you methane. The other method is from the beryllium carbide. Again, you will do that same thing of exchanging the valency and that kicking out the common part. So for BE, it is your what will be the valency? It will be 2. For carbon, it will be 4. Then kicking out the common part will give you B2C. Again, you do the hydrolysis and you will get the methane. So remember these methods. So we have talked about 5 methods. First is hydrogenation of alkene. Second is treatment of your alkyl halides with zinc and hydrochloric acid or your Woods reaction which involves metal. Then your carboxylic acid, which includes decarboxylation of the sodium salt of carboxylic acid or the electrolysis of the sodium salt of carboxylic acid. Next is the Grignard reagent. Again, we do the hydrolysis here, means the reaction with water, and we will get the corresponding alkane. And lastly, we have some notable representations as Al4C3 or beryllium carbide. So here we are treating the carbides of aluminum and beryllium with water to get the methane. So this was all about the preparation part of the alkanes. Next, we will see some physical properties of alkanes. First one is the boiling point. So it's very obvious. Your boiling point will increase with the increasing molecular mass because boiling point is dependent upon the intermolecular force. In case of alkanes, since there is no dipole-dipole interaction, so the only intermolecular force that is the most dominant one is your van der Waals force. And van der Waals force is completely dependent upon molecular mass. Or we can say that it is directly proportional to the molecular mass. So if you increase the molecular mass, you will increase the boiling point. Then, what about those molecules which have comparable or equal molecular mass? So that is decided by the branching. So more is the branching, less will be the boiling point because branching decreases the surface area, and surface area is something which is important for the van der Waals force to act upon. Okay, so if you have pentane and if you have neopentane, then you will obviously see that neopentane has a smaller area. As a result of that, neopentane has a lower boiling point as compared to the normal longer chain pentane which has less branching in it. Next, melting point. So again, melting point increases with molecular mass, but it is seen that the molecules with comparative molecular mass are seen to have higher boiling point for those molecules which are symmetrical in nature. Okay, so if you take two molecules which are having different structure but they are having comparable molecular mass, then one with the symmetrical nature is seen to have higher melting point. Why is it so? Because melting point is related to the melting of solid structure, and solid structure are being more concurrent if they are formed from symmetrical molecules. Now, what is the meaning of symmetrical molecule? For example, if you take a isobutyl and you take a secondary butyl, then secondary butyl will appear more symmetric as compared to the isobutane. Okay, so this is very, very important to remember, and this will help you in the upcoming comparison of your alkane. Suppose if you compare the ortho and para, it is seen that the para one is generally more stable. Why? Because para is symmetrical in nature. You can cut the para in between and you will get two equal halves. Got it? Suppose we are talking about a molecule which contains benzene And in that benzene, in the first position, we have chloro, and on the fourth position, that is your para position, we have the methane. So it is a symmetrical molecule. If you cut it in between, you will get two equal halves. So it is symmetrical molecule, hence it will have a higher melting point as compared to the orthotoluene, in which the bromine is attached to the ortho position of the toluene. Next, if this is true, then alkanes which are having even number of carbon atoms have higher melting point because they are symmetrical in nature, right? You can cut it into halves. That cannot be said about the odd number of carbon atoms. So if you compare pentane and your butane, the butane is having the even number, so it will have a higher melting point. Next, polarity. So polarity means whenever you get a polar molecule upon the separation of a positive and negative charge, and they are separated by a small distance, then we say that that given molecule is polar in nature. But for the separation of charge to occur, you must have a difference in electronegativity. But your alkane is only containing carbon in it, in the whole skeleton structure. So there is no such highly electronegative element or highly electropositive element which can disturb the polar nature of your alkane. Okay, sorry, non-polar nature of your alkane. So it is completely non-polar in nature. You can take examples of petroleum, benzene, all are non-polar in nature. And lastly, your density. So it's very obvious that density will increase with the molecular mass, and it has a limiting value of 0.8 gram per centimeter cube. So after that, you won't see an increase in the density, although you keep on increasing the molecular mass. So these are some important points regarding the physical properties of alkane. So just wait for a while, I will be there in a minute. Sorry for the interruption. Now, next we will see the chemical properties of alkane, starting with the first one, which is halogenation of alkane. Now, what is halogenation? As you are getting it from the word, we are trying to add halogen to the normal alkane chain. The one method which is used to do so is the free radical substitution. So this process is done under the presence of your ultraviolet rays. How does the process occur? The process occurs through the process of radical reaction. Okay, radical reaction mechanism. We'll see onto it later. Before that, we should learn that of all the hydrogens that are available, which hydrogen will be replaced with the halogen. It is generally seen that 3-degree hydrogens are first of all removed, then the 2-degree and then the 1-degree. We know about this differentiation of 3-degree hydrogen, 2-degree and 1-degree. We studied this in the past. Now, talking about this, we will do an example. Suppose we started with a methane, then we want to do the halogenation, but here is a problem. It is not very efficient to do the halogenation of your alkane with the help of this method, because it is a process which is very violent in nature and highly reactive reaction. Why is it so? As soon as you see a single substitution, this reaction doesn't stop at that point. It will remove the hydrogens till and until all the hydrogens are being replaced by chlorine. You can see the series of reactions here. So one hydrogen is being removed, then second, then third, and then fourth. So it is a very aggressive reaction. And in this process, we can get a multiple type of product mixture in the same reaction mixture. Now, you can also carry out the bromination as well through the same way, but it is slightly slower as compared to the chlorination. So these two processes are used for the halogenation, but you can't do the iodination or the fluorination, because fluorination shows a very violent nature because of the strong bond between carbon and fluorine. As soon as you do this reaction, whenever a carbon and a fluorine bond is formed, a huge amount of energy is released, which is showing that it is a highly exothermic reaction and cannot be used in the preparatory method of your fluoroalkanes. What about iodination? In case of iodination, it is reversible in nature. Means the product that is formed can be reverted back to the reactant part. And that is something which is very difficult to control. So if you want to do the bromination and chlorination, this process is good. but still you will get the mixture of product. But it is not at all efficient for the iodination and fluorination, because for iodination the process is reversible, and for fluorination it is too vigorous. Okay. Now let us understand the mechanism of the same. So this reaction involves homolytic cleavage. So there are two kind of bond breaking. One is homolytic and second one is heterolytic. In homolytic, the electrons of the bond are distributed equally between the partners, whereas in the heterolytic, the distribution is unsymmetrical. So let me just make it clear with the help of your homolytic reaction. See, there is a bond between chlorine and chlorine. In this bond, there are two electrons. So the two electrons will be distributed onto the both chlorines equally. Therefore, you are getting two radicals of chlorine. See, a dot is given upon the chlorine to represent that one of the electron of the bond is with one chlorine and the other electron is with the another chlorine. So these are the two chlorine free radicals. And this is your initiation part. How you will identify that whether a given process is initiation or not? Remember, in the initiation, in the left part we will have no radical, in the right part we will have radical. And that is obvious because in this process, this is the initiating part, mean it is creating your radical. So of course, you will first have no radical and then have radical on the next part, on the react product side. Then we have propagation. Propagation includes the passing of radical from one molecule to another to create different other free radicals such as methyl free radical. So we got this chlorine radical, it will react with the CH4, and in that process it will get attached to the hydrogen. Okay. So basically one of the bond of your carbon and hydrogen is broken homolytically and hydrogen gets a radical and that pair ups with the radical of the chlorine creating a HCl molecule. Got it? Now next, how can we call it as a propagation? Because the radical is propagated from one part of the molecule to other species, say from chlorine to methyl radical. Got it? How do we identify this? So it's very simple. If you see radicals on both sides, then this is a clear indication that your given step is a propagation. Then similarly, we can have multiple propagation steps. This can be reverted in the opposite direction also, that your methyl radical breaks a chlorine molecule to give you a chlorine radical and a required halogenated product. See, we got the methyl chloride. Next, as I said, multiple time halogen is possible. So that is being shown here. How? So basically, one Cl radical again reacts with the CH3Cl to give you the CH2 radical Cl and HCl. And this CH2Cl radical again reacts with another molecule of chlorine to give you CH2Cl2. So first of all, we got a monochlorinated alkane and then a dichlorinated alkane. Similarly, this can be again broken up by the chlorine radical to form CH2 radical Cl2, and this will again react with the Cl2 molecule to give CHCl3. Okay, so these are the subsequent steps that can go on forever to create a tetra substituted methane with 4 chlorine on the carbon atom. Next, the last one is the termination step. So as the word says, here we will get no radical at the end of the reaction because here we are terminating the reaction. So for first reaction is given here between two chlorine radical in which they are combining together to give the chlorine molecule. What is the indication that this is a termination? Because on the reactant side we have radical, on the product side we have no radical. So let me just make it clear for you. In the initiation we have radical on the product side. In the propagation we have radical on both sides, reactant as well as product. In termination we have radical only on the reactant side and not on the product side. Now here is a very important reaction and there is a question from the same. Can we create a carbon of alkane of a longer chain? Yes, it is possible. In the reaction itself you were getting methyl radical. Now two methyl radical can just couple with each other to form the ethane and give you a longer carbon chain. Similarly, it can always give you your required halogenated product. And due to the consumption of the free radical in all these three processes, this reaction, these steps are known as chain termination steps, because in all of them, chain is terminated by consuming the radical. Moving on to the next, we have controlled oxidation. So just wait for a while. I will be there in a minute. So this was your first reaction in which you did the halogenation of your alkane. Our next is controlled oxidation. Now, in terms of your organic chemistry, you will mainly see your oxidation term with related to those reactions in which the oxygen is added to the given substrate. So, can we see an example of it? Yes. Now, what do you mean by controlled oxidation? So, basically, you can have various oxidized species of the same given compound. So, you can either oxidize your given compound, which is an alkane, into alcohol, or to the next oxidized form, which is aldehyde or ketone, or to carboxylic acid, or even to the highest oxidized state of carbon, which is carbon dioxide, okay, which is CO2. Now it will depend upon the catalyst that we are using and the temperature and pressure that we are maintaining. Suppose we have methane, we can oxidize it to methanol if we do it in the presence of copper catalyst and at 523 Kelvin and 100 atm pressure. Next, you can also oxidize the same methane to the next higher oxidized form, which is your aldehyde. In this case, we have used a better catalyst, which is molybdenum oxide, MO2O3, right? After that, we can also directly oxidize it to the carboxylic acid by using a salt of manganese, which is manganese acetate. Okay, see, we have CH3COO2 Mn. In this case, what will happen? Your given ethane is oxidized to the acetic acid. So see, depending upon the catalyst that we are using, we are getting different oxidized form. In the first case, we are getting alcohol with the use of copper and at high elevated temperature and pressure. Then we can get aldehyde if we use the oxide of molybdenum, and if we use the manganese acetate and heat it, then we can get the acid as well. Right? Now, your ordinary alkanes resist oxidation, but the isoalkanes, means the 3-degree carbon, if you just oxidize it with the KMnO4, then it can give you tertiary alcohol. So this is your example. So CH3 whole thrice with CH, if it is oxidized in the presence of KMnO4, then it will give you a tertiary alcohol where the hydrogen is being replaced by the OH. Again, this is a classic example of your carbon getting oxidized under the presence of a very strong oxidizing agent known as potassium permanganate. I hope this is clear to you. So if you have a doubt, you can just post it here now. Anyone who has a doubt in this? Now, the next reaction is isomerization. So this is the third reaction. First was your halogenation in the presence of UV light and chlorine molecule. Then we studied about the oxidation, about various types of oxidation depending upon the catalyst that we are using. Now, what do you mean by isomerization? What do you mean by this? We have not heard this term before, but you have heard about this isomers, right? Now you would be getting an idea. So basically, in this process, we keep the molecular structure formula same. We are only changing the structure, or we are converting into a different isomer. Now, how can we do it? So first of all, you will use a Lewis acid. For that, we can take AlCl3, anhydrous AlCl3 and the HCl gas. What will happen here? With the reaction of your normal alkane, which is a straight chain, it can be further isomerized into a branched chain alkane. Now, this process is used many times in your exam questions. Okay, you will see that you are using a AlCl3 or other catalyst which act as an acid, and they isomerize your given chain into a smaller chain or a branch chain. Here is an example of the same. So we have taken a carbon chain of length is equals to 6. Now what we are doing, we are treating it with the anhydrous AlCl3, which is aluminum chloride and HCl. So this HCl is creating your carbocation, and this carbocation is rearranging itself to give you a stable carbocation. In that process, we are getting a branched chain. How can we identify it? So see, the CH3 is being attached to this carbon. Now why it has happened? Because your carbon radical, your carbocation is very much stable, right? As a result of this, this carbocation is formed, which is 3 degree in nature, and next the methyl must have attacked this carbon to create a branched chain. Now you can have multiple type of product possible from this. This CH3 can also go into the middle carbon and hence can create this type of structure in which we have one C2H5 on the left, one C2H5 on the right, and in between we have C, and the end CH3 is attached to the middle carbon to give you a isomer of the starting reactant. Now next one is isomerization. So what is aromatization? We have not studied about aromatization till now, but we are taking a simple aromatic compound which is already known to you, and that is your benzene. So basically, we are starting with an alkane, and we are aromatizing that into the benzene. And how we are doing it? By taking an elevated temperature such as 773 Kelvin and an elevated pressure that is 10 times the atmospheric pressure or 20 times the atmospheric pressure. So this enhances your reaction rate, and next we are using a catalyst also. So that can be oxide of vanadium or molybdenum or chromium. Remember, we can use oxides of all of them. Now, in the reaction that I'm showing you right now, in this we have specially taken the oxide of chromium or the vanadium. But remember, you can also use MO2O3. We have seen it in the previous part. You can also use the same here also. What you can do, you can just treat your normal hexane, which is your six membered chain, and then you can treat it with molybdenum oxide in the presence of elevated temperature and pressure to get a cyclized chain, which is benzene. Got it? Now, why we are calling it as aromatization? Because we are converting a normal aliphatic chain into a aromatic compound, which is benzene. And why this reaction is occurring? Because aromatic compounds are highly stable than non-aromatic compounds. So this reaction is viable and very much efficient as well. Now, moving on to the next reaction, which is with the steam. Steam means simply water vapor. So at 1273 Kelvin, if you do the reaction of your alkane with the hot water vapor, at the surface of the nickel. Okay, so nickel is providing the surface for the reaction. You know it very well that your reaction conditions are enhanced if the reaction is done on greater surface area. So here we are using nickel for it. What will happen during this reaction? Your carbon will be oxidized, and that will be a partial oxidation of it to carbon monoxide. Okay, we are not getting carbon dioxide, we are getting carbon monoxide and hydrogen. So this gas mixture is used for the industrial preparation of the H2 gas. Next, you can also do the sixth type of reaction, which is pyrolysis or cracking. The term is suggesting that we are breaking a greater molecule or a greater alkane into small parts, and that is the reaction that is occurring during the pyrolysis. So what we do, we take higher alkane and we treat it with a very high temperature. In this process, your higher alkane, which is suppose C6H14, so 6 carbons are there, they can be broken down into multiple fragments such as C6H12, C4H8, C3H6, C2H4. So you are getting a series of products, okay, a mixture which is very difficult to separate, but this reaction occurs, and this is known as cracking because we are breaking a single chain into multiple fragments to give you a mixture of hydrocarbon. So this was all about the chemical properties of alkane. Now we'll move on to the conformations. Now what do you mean by conformation? As I said it earlier, that your single bond has a property to allow rotation around it because it has no constraint of pi bond. As a result of this, your spatial arrangement of your molecule, of your atoms of the molecule can be changed by this single bond rotation. And the resulting thing that we are getting are known as conformers, and this phenomena is known as conformation. Now, your ethane molecule is something which is important for your class 11th and 12th and your JEE exams. So its conformations are very, very important. So there are three stable conformations of your ethane. First one is eclipsed one. Whenever your all the hydrogen atoms are close to each other or are next to each other, we call it as eclipsed conformation. So this is the conformation with highest energy and it is highly unstable. Next is the staggered conformation. Here, the hydrogen atoms are present as far apart as possible. Since the interaction between the electrons of two hydrogen is very less, therefore, the conformation is highly stable and it is having the minimum energy. Lastly, we have this Q conformation. So in this case, the proximity between the two hydrogen is neither maximum nor minimum. It is intermediate in between, and hence the energy is also intermediate between the staggered and eclipsed of the ethane. So these are the three conformations of ethane that are possible. Now it is very difficult to understand this if I am just saying it. To make it easier, we use something known as projection. Okay, so these are simply methods to represent the overall molecule through simple notations. So two of them are very well known. One is Sohers and the second one is Newman. Talking about the Sohers projection. So this is the way we represent the eclipsed and staggered form of the ethane using Sohers projection. How can we just identify that the given one is eclipsed? See here, this hydrogen and this hydrogen both are pointing upward, meaning that the bonds are oriented in the same direction for all of these three hydrogens, rather either in the front one or either for the back one. So this is the front carbon and this one is the back carbon. Similarly, if I talk about staggered, then in this case, if the hydrogen is pointing, one of the hydrogen is pointing upward, then the other back one is pointing downward. Therefore, they are as far apart as possible, right? Now this can be said about each and every hydrogen. For example, if this is pointing towards right side, the other hydrogen in the back carbon is pointing onto the left hand side, and that same can be said about this hydrogen. Now to give a more clear picture of this, we can have Newman projection. So here is the example of Newman projection of your ethane. So in the eclipse part, you can see that how your both hydrogens are aligned in a single line. If you see it from the straight line, then you will not see the back hydrogen, although it is represented here to just show it to you. But if you are literally seeing it, then you won't see the back hydrogen. But if you consider the staggered one, then in that case the angle is present at a the hydrogens are present at a certain angle, and this angle is known as the torsional angle or the dihedral angle. Okay, what do we call it? We call it as the torsional angle or the dihedral angle. Now in the staggered conformation, this angle is 60 degrees, right? This is 60 degrees to each other. There is an important point here. We were saying it that yes, eclipsed one is more stable, staggered one is more stable as compared to the eclipsed one in the case of ethane. What is the reason behind it? The reason is that there are two strains here. What are those two strains? First one is the torsional strain and second one is the steric strain. In case of hydrogen, which are close to each other, they won't show steric strain. So it is shown between two atoms or two groups. Since the size of hydrogen is very small, so steric strain is not seen in case of ethane. But in place of that, suppose we have methane here and methane in the backside also. So that can result in the steric strain. The second type of strain is the torsional strain. What is torsional strain? It happens due to the repulsion of your electron density. So basically, this carbon hydrogen bond must have some electron density if we talk about the front carbon, and the same can be said about the back carbon. Both of this electron density repel each other, and that creates the torsional strain. But this torsional strain is not seen in the case of your staggered structure because the electron densities are far apart from each other. As we said earlier, in this case the hydrogens are placed apart from each other and hence the repulsion between the electrons is also less. Now, it is generally seen that the energy difference between the eclipsed and staggered form of ethane is 12.5 kilojoule per mole. And this energy difference is very less. As a result of this, the eclipsed and staggered form are interconvertible at your room temperature. And hence, they cannot be isolated. If you want to isolate the eclipsed form, it will take up the energy from the environment and it will be converted into the staggered form because of the lower energy difference between these two. Got it? Now, moving on to alkene. So we have talked about the alkane, the physical properties, the conformation, the preparation, and the chemical properties. Now, we'll move to the alkenes preparation. First method is controlled hydrogenation. Similar to the case of your alkane, alkenes can also be prepared, but this time through controlled hydrogenation. So we take the alkyne, but we do not convert directly it to the alkane, but we keep it to the intermediate part, which is your alkene. Okay. Now it can be done through two methods. First one is through Lindner catalyst, and the second one is through the liquid ammonia and sodium metal. What is the difference between these two? The first one, which is Lindner catalyst, it will give you an alkene which will be of cis configuration, means the similar kind of group will be on the same side. Whereas in the case of your liquid ammonia and NH3, which is also known as Birch reduction, the product that you will get will be of trans configuration. So here is an example of the same. Suppose we started with the alkyne and we are treating it with the H2PDC, right, which is your Lindner's catalyst. What will happen? We will get a cis alkene. See, both hydrogens are present adjacent to each other. Now in place of that, suppose you use sodium and liquid ammonia. What will happen? You will get trans alkene, because in this case the hydrogens are present on the diagonal part. Okay, you can see here, if you just draw the diagonal, you will get hydrogen on the ends of the diagonal. Got it? So this is a very important difference between the two methods, and this thing is obviously asked in your exam in multiple cases. Now moving on to the next type of reaction, which is dehydrohalogenation. As the name suggests, it is removal of hydrogen as well as halogen. And for that, we simply treat our alkyl halide with alcoholic potash, KOH. Okay. The reaction is known as beta elimination reaction. Why we are calling it as a beta elimination reaction? Because hydrogen is removed from the beta carbon. How do we know that which one is beta carbon? It's very simple. We have to use the alpha beta naming to know the beta hydrogen, right? Now coming on to the nature of halogen atom removal. So iodine is removed very easily. It quickly results in the alkene. If your halogen is iodine, then the bromine, then the chlorine. Talking about the alkyl group, the 3-degree alkyl group gives the fastest reaction, then the 2-degree, and lastly your 1-degree. So what do? We take alcoholic potash, which is alcoholic KOH, and if you treat it with the alkyl halide, that quickly results in the required alkene. The reaction goes through your ZZF product, and the order of reaction is fastest for iodine, then for bromine and chlorine. Regarding the alkyl group, it is fastest for 3-degree carbon, then the 2-degree, and then the 1-degree. So let me give you the third method, which is dehydration of alcohol. So dehydrohalogenation means removal of hydrogen and halogen. Dehydration means removal of water. How can we remove water from alcohol? For that, we will use concentrated H2SO4 and treat it with that at elevated temperature. As a result of that, the H2O will be removed from the corresponding alcohol. So we have taken 3-methyl-butanol. After the reaction, what is happening? You are getting 3-methyl-butene, but2ene. Now, what is the reason behind it? Why are we getting it at second position? We should have got it at the first position, right? Because OH is present at the terminal carbon. So basically, this reaction goes through the formation of carbocation. First of all, the H plus will be rotated from H2SO4 to create a H2O, which is a leaving species. So it will leave the carbon and create a carbocation. Next, there will be a hydride shift, creating a stable carbocation, which is 3-degree in nature, right? Lastly, what will happen? The remaining hydrogen will be eliminated, and we get our required 3-methyl-but2ene. So basically, your dehydration and dehalogenation, both of them are governed by the ZZF rule, meaning that hydrogen is removed. The greater is the number of alkyl group attached to the double bonded carbon, the more stable is the alkene, because this carbon has the greater number of carbon attached to it, so it will have a stable alkene formation as compared to this carbon, which has only one carbon attached to it. Got it? Now, moving on to the next one, which is dehalogenation. It's very simple. Here we are only removing halogen. So what we do, we treat our vicinal dihalides in which the halogen are attached to onto two adjacent carbon. Then we treat it with the zinc metal. The zinc metal will remove the two halide atoms, creating a alkene. Got it? Suppose we are taking 1,2-dibromoethane. If we treat it with the zinc, both of the bromine will be gone along with the zinc, and that will give you your ethene, which is the required product. Our next is the reactions of your alkene. So we are done with the preparation method. Now we will move on to the reaction. The first type of reaction which is shown by the alkene is the electrophilic addition reaction. What do you mean by electrophilic? Means electron loving. Okay. How do we understand it? So we'll try to understand the same with the help of its mechanism. You know that your alkene consists of a double bond in which one is sigma and the other one is pi. Because of the weaker pi bond, which are loosely held to the carbon atom, they are easily broken, and hence your alkene is capable of giving the electrophilic addition reaction. So let me show you how does this happen. What is the mechanism for the same? First of all, you will see that there is a generation of electrophile and nucleophile, and that can be done upon ionization. So this is your reagent. So it can be broken into two parts. Got it? E and NU. Suppose we take Grignard reagent RMgX. So it can be broken into R minus and MgX plus. Got it? So R minus will be your nucleophile and MgX plus will be your electrophile. In this way, multiple reagents are broken. Now next, your electrophile will attack onto the alkene because alkene is electron rich in nature. It has a pi electronic system attached to it. So this pi electrons will be donated onto the electrophile, creating a carbocation. See here, one of the pi bond is broken along with the carbon. It is gone onto the next carbon, creating a bond between the carbon and electrophile, and hence a carbocation is formed here. What will happen? The nucleophilic part that is remained in the reaction mixture of the reagent, it will now attack to the carbocation to give you the final product. See here. So the first one is a slower process because we have to break the bond between the two carbons. The next one is a faster one because in this process your positively charged carbon is being neutralized by the negatively charged nucleophile, which is kind of stabilizing the product. So this mechanism will be followed for each and every reaction. First of all, we have addition of hydrogen. So if we have seen the addition of hydrogen in the presence of palladium, platinum and nickel, how does it happen? So as soon as you treat it with the hydrogen, the pi bond is broken between the two carbon and the two hydrogens are added onto it. Next, addition of halogen. Similar to the addition of hydrogen, the two halogen atoms can be added in a Wisnel fashion to create a Wisnel diline, meaning that the both of the halogen will be going on to adjacent carbon. And this reaction is not done under normal condition. For iodine, we have to use a reagent that can, or we would say a catalyst that can reverse the reaction, because similar to the case of your iodination with the help of UV light, this iodine addition is also reversible in nature. Got it? So you have to absorb one of the side products so that the reaction cannot be reversed. We will talk about this in detail in the haloalkane and haloarenes, or the organic compound containing halogen. Next is addition of hydrogen halide, which is HX. It can be HCl, HBr or HI. These three can only be used. So if you add it to the alkene, what will happen? This halogen will be attached to that carbon which will be connected to maximum number of carbon, or that can create highly stable carbocation. So this is according to the Markovnikov rule, which says that the negative addendum of your hydrogen halide, which is your halide, will go on to that carbon which creates stable carbocation. So here is an example for the same. So we have two carbon here which are attached to the double bond. Out of these two carbon, the middle carbon will form a highest stability, a carbocation of higher stability, because it is attached to two other carbon atoms which will stabilize the carbocation. As a result of this, the X part of your hydrogen halide will be going on to the middle carbon, and this will be your major product. The minor product will be one where your halide will be going on to the terminal carbon. Got it? Then next is addition of hydrogen halide has a proper mechanism. What is that mechanism? First one is the attack of H plus, which creates the carbocation. See, if this is your alkene, which is your propene, if you add HBr to it, what will happen? The H can go on to two places. Either it can go onto the terminal carbon or onto the middle carbon. If it is going to the terminal carbon, then it will contain a 2 degree, it will create a 2 degree carbocation, because the middle carbon will be lacking of the electron. or else it will form the 1 degree carbocation if your H of the HBr is going on to the middle carbon. See, it is now CH2 rather than CH. So this will create a 1 degree carbocation which is less stable. Now the question is that which will be formed in bulk? Of course the second one, because it forms the 2 degree carbocation. After that, since this one is formed in the major amount, therefore Br minus will mostly attack these molecules which is of 2 degree nature and hence create our required 2 bromopropane. Got it? Suppose bromine attacks this carbocation, but the problem is that the 1 degree carbocation is very less stable. It is formed in minute amount. Therefore, this product which is creating bromine at the terminal carbon is formed in minor amount and it is known as the minor product. Whereas if the bromine is going to the middle carbon, it will form the major product. Now, is there any way to make your bromine attack onto the terminal carbon rather than the middle one? Yes, but it is only possible for bromine, means HBr only. And the effect is known as the Kharash effect. It is just opposite of the Markovnikov rule. So you can also name it as anti-Markovnikov rule. Basically, if you add your HBr onto the alkene in the presence of benzoyl peroxide, then what will happen? Your bromine will be attached onto the terminal carbon rather than the middle one. You can clearly name the compound as 1 bromopropane. So this is the major product rather than 2 bromopropane, which was seen in the case of normal addition. Okay, I hope this is clear to you. Now, what is the reason behind it? We know the mechanism for first one. The stability of the 2 degree carbocation is resulting in a 2 bromopropane. But why are we getting 1 bromopropane here upon the uses of this benzoyl peroxide? To answer this question, you have to look upon the mechanism. So your peroxide effect or your Kharash effect is seen due to the formation of radical. So the whole process goes through the radical chain mechanism. What are the steps? First one, this is your benzoyl peroxide in which we are seeing that the 2 oxygen bonds are present in middle. Okay, and on the either side we have benzoyl point. So this is the peroxide part, OO, and the benzoyl part is on the left and right. Now, in the presence of sunlight, this will undergo homolytic cleavage to give you 2 radicals. First radical is of C6H5 dot type and the second radical is of C6H5COO radical. In the first case, radical is present on oxygen. In the second case, it is present on carbon. Along with that, we have the carbon dioxide as well. Now, the phenyl radical that you got, which is C6H5 dot, that will react with the HBr. The first step is the initiation, because in this one you are getting radicals on the right hand side and there were no radical on the left hand side. But in the second part, you are seeing radical on both sides, on the reactant as well as the product side. So this is an example of propagation. Lastly, you can have multiple propagation, like the alkene that you got here. Okay, the alkene that you got here, that you started with, will react with this free bromine radical to form 2 types of radical. If this bromine radical attacks on the middle carbon, then it will create a less stable primary free radical, because primary radical are less stable as compared to the secondary radical due to the presence of hyperconjugation and your inductive effect. Okay. Now, if the bromine goes on to the terminal carbon, then that will create a secondary radical. So these are the 2 possibilities. Either your radical is formed along with the middle carbon or with the terminal carbon. In case of terminal carbon, you are getting a more stable secondary free radical. Therefore, this is formed in the B is formed in the major amount. Now what will happen? The next step would be the abstraction of hydrogen from the HBr, and this will give you your major product, which is 1 bromopropane. See the reaction, how it is going on. After that, we can again see homolysis of the same. So this will again abstract 1 hydrogen from the bromine, creating our minor product. Right? So this is our possible minor product. So this was all about the addition of hydrogen halide. Now we'll move on to the addition of sulfuric acid. It's very simple. If you treat your given alkene with H plus and that H plus is coming from H2SO4, then H plus will go on to the terminal carbon, creating a negative or positive charge on the non-terminal carbon, which is doubly bonded, okay, which is attacked further by the OSO2H to give you the corresponding alkyl hydrogen sulfate. And in this reaction, we get a intermediate carbocation which is secondary in nature. Got it? Then the next type of addition reaction is addition of water. So if we add water onto an alkene in the presence of an acid such as H2SO4, what you will get? You will get OH addition onto that carbon which has greater number of carbon attached to it. So here also the reaction goes through the Markovnikov route. See, the OH is getting attached to the middle carbon which is a 3-degree carbon and not to the terminal carbon which is a 1-degree carbon. Then we have hydrogen of addition of hypohalous acid. Now what do you mean by hypohalous acid? So a hypohalous acid consists of two parts. First is hypo, which is OH, and the second one is halous, which is representing the halogen, OH and X. Now in these two parts, which one will be the negative and which one will be the positive? It's very obvious. OH will be the negative part and X will be the positive part. Got it? So if you are adding it to an alkene, the X plus, where it will go? It will go on to the terminal carbon, right? And that will create a stable carbocation. Here we don't have any such criteria, but in the general case where there is a possibility of formation of two types of product, there the X plus will go on to that carbon which is having less number of carbon attached to it, so that we can get a stable carbocation. After that, the OH will attack onto the formed stable carbocation, resulting in the required product. Got it? Then next we have an important method which is used for identification of alkene. This is known as Bayer's reagent, which is cold dilute potassium permanganate. What happens in this reaction? So the potassium permanganate oxidizes your given alkene to form a dihydric alcohol, a vicinal dihydric alcohol, I would say. Now what is the meaning of vicinal? I have repeated it multiple times. Means both of the OH group will be attached onto adjacent carbon. Suppose we started with ethene, then if you treat it with what? Cold dilute KMnO4, which is occurring at 273 Kelvin, means 0 degrees Celsius, which is obviously a low temperature. It will result in the addition of OH onto two adjacent carbon which are doubly bonded to each other, creating ethane 1,2 diol. Now, if you treat your given alkene with KMnO4 or K2Cr2O7, which are acidic in nature, that would create ketone or acid, because acidified KMnO4 or acidified K2 or Cr27 are stronger oxidizing agent as compared to the normal KMnO4. Here is example of the same. If we are treating our given alkene with KMnO4 in the presence of an acid, then that would result in carbonyl compound. The terminal carbon is converted directly onto the oxidized form, the most oxidized form of the carbon, which is carbon dioxide. So if your alkene is terminal, it will result in carbon dioxide. And the middle carbon, it will be converted into your ketone. Got it? Apart from this, we can also get H2O. But suppose the two doubly bonded carbon, in the two doubly bonded carbon, both were not of the what terminal type, then that would result in two ketones and not the carbon dioxide. So this should be always there in your mind. Next is a very important reaction for your alkenes, which is ozonolysis. So how does the ozonolysis take place? First of all, your ozone, which is O3, is added to the alkene to form the ozonoid. Next, if you treat it with the reducing agent, your ozonoid is being reduced to what? To your corresponding aldehyde, ketone or alcohol, depending upon the substance that you are using for the cleavage of the molecule. For example, if we start with propene and if we treat it with the ozone, then we get propene ozonoid, right? Next, what will happen? The Zn and H2 will be added to it. Remember, here we don't have a bond between the two carbon. If you do the same reaction along with alkyne, you will see that one bond is remained between the carbon and carbon, right? And it is not seen in this case. Next, if you treat it with the zinc and H2O, the bonds will be cleavaged and you will get ethanol or methanol as the two parts. Got it? Moving on to now alkynes. So we have talked a lot about alkenes. So now we will talk about the preparatory methods of alkynes. So starting from the metal carbide. what do? Is we treat the calcium carbonate with heat to produce calcium oxide and carbon dioxide. Then in the next part, we treat our calcium oxide with carbon to give the calcium carbide, and lastly, this calcium carbide is treated with water to give you the alkyne. Now this method is very important and it was asked in your JEE exams as well. So you should also remember the precursor steps which are required for the formation of calcium carbide. So first we are decomposing calcium carbonate, then further we are treating it with carbon to form the calcium carbide, and then we are hydrolyzing it to give you your corresponding ethyne. Okay. The next method which is used for the preparation of your alkynes is from vicinal dihalide. Again, we know about this vicinal dihalides, halides which have uh, two halogens present on adjacent carbon. If we treat it with the potash or your alcoholic KOH, then it will go under dehydrohalogenation 2 times to give you the alkyne. So if you do it 1 time, you are getting alkene. If you do it 2 times, you will get alkyne. So you can see here the 2 bromine atoms are removed in 2 steps. So first of all, 1 bromine atom is removed to give you the alkene. In the second part, the second bromine atom is removed to give you the alkyne. So this is your overall reaction of your vicinal dihalide to form the alkyne. Now, how do we form higher alkynes? So this group of higher alkynes can be formed from lower alkynes if we treat sodium acetylide with the alkyl halide. Now what do you mean by sodium acetylide? It's very simple. When you treat an alkyne with sodium and liquid NH3, it acts as a base and abstracts the proton from it. Got it? Resulting in the formation of RC triple bond C single bond Na. Now, so here it will be CH, not H directly, it will be CH. Upon the removal of this H from it, you will get RC triple bond C Na. Then you will treat it with the alkyl halide. This C minus will act upon R dash X, removing the X from it and creating a longer chain. So first what we have done, we have converted our alkyne to a salt by treating it with a base. So this is an alkyne, we treat it with the base to get a salt. Next, the salt that we got, we treat it with the alkyl halide. So this negative part of your carbon will attack the alkyl halide to form the corresponding alkyne. Then reactions of alkynes, first is electrophilic addition. Very simple, if you treat it with dihydrogen, it can be converted to alkene and then what? Alkane. Next, addition of halogen. Again, this will result in tetra substitution. The first bond will be removed and it will result in di substitution. The second bond will be removed and it will result in tetra substitution. After that, we can add also hydrogen halide. So this can also be done 2 steps. In the first step, we will add HX and then again we will add HX. In both of the steps, X will be added on to the that carbon which is highly stable and it will create CH3CHX2, means that carbon which is following the Markovnikov's rule. Last we have addition of water. So if we add water to the alkyne in the presence of an acid, then first of all it will result in an enol. So this is your enol and this enol will tautomerize further to give you the corresponding aldehyde which is ethanol in this case. Next chemical property is regarding the acidic nature of alkyne. We have seen the reaction in the previous preparation. When we were treating our alkyne with a base, it is donating one of its proton to get you the sodium salt of acetylide. Okay. So this reaction is very important. You can see here that upon the reaction of sodium in liquid ammonia, we were seeing the cleavage of carbon and hydrogen bond, that carbon which is triply bonded. And this is the reaction that I was talking about. See, we have started with the alkyne. Upon treated with sodium, the H is removed from one part to give you CH triple bond C minus Na plus. Then next what will happen? We can use another type of base. Here we are using AgNH3 whole twice OH minus. Again this OH minus can abstract one proton from it and it can do removal of hydrogen in 2 steps and that would result in addition of Ag onto the 2 carbons and this thing will be formed as the white precipitate. Now next one is oxidation. So if you treat your alkyne with your hot KMnO4 in the presence of an acid, that means acidified KMnO4, it would result in 2 corresponding acids. So one is from the first half of your alkyne, and second is from the second half of your alkyne, if you are using an unsymmetrical alkyne. Now, as I told you in the start, when we are talking about the ozone in the case of alkene, we were not seeing a bond between the carbon. Here we are seeing it because we have 3 bonds in total. In this case, 2 possibilities are there. If you use zinc H2O, that would result in simply formation of oxo compound. But if you use a stronger oxidizing agent again, that is H2O2, then it will give you the corresponding carboxylic acid. So remember these two scenarios. These are very, very important. After that, this is a method which is also used in the preparation of benzene, where we take alkyne, which is especially your ethyne, and then we aromatize it in the presence of elevated temperature in red or iron tube. So this is a very exaggerated reaction in which we use high temperature and pressure to control the reaction and give the aromatic hydrocarbon, which is benzene. Now we will move on to aromatic hydrocarbon. What are aromatic hydrocarbons? So aromatic hydrocarbons are highly stable hydrocarbons, and it is stabilized due to the delocalization of pi electrons across the whole ring. Now there are certain characteristics for a given compound to be aromatic. First one is it should be planar. Second one, it should be showing complete delocalization of pi electron. And the third one is that the count of pi electron should be equals to 4n plus 2 pi. So this is your Huckel's rule. One more important thing, and that is very obvious. So it should be cyclic in nature. Starting from a species, say we are starting from the cyclopentadiene anion. Here we have how many electrons? Pi electrons. So 2 from the double bond. Sorry, 4 from the double bond and 1 from the and 1 pair from the negative charge. That will give you a total of 6 pi electrons. If you equate it with 4n plus 2 pi, what will happen? It will give you an integral value of n, and that is something which is acceptable. If you are not getting an integral value, then it is not acceptable at all. Got it? This given system of aromatic nature is non-benzonide in nature because it is not containing any benzene ring. So we have seen this classification earlier also. There are many examples which are non-benzonide in nature, like pyrrole, furan, and we have pyridine and all. Talking about the benzene, so benzene is known to have a resonance hybrid structure. See, there are 2 structures possible for benzene, right? So the double bond can be present in 2 ways. So it is given here, and you can easily see the difference between the two. Now, how to represent it? Which is the best method? So rather than representing it by a single structure, we use a resonance hybrid, that is a combination of the two. You can see it very clearly here that we are representing the resonance hybrid of your 2 possible structure with a circle. It shows that electron is not present at one carbon, it is being delocalized over the entire structure. Here, if we consider what are the number of pi electrons, so 3 double bonds are there, that would result in 6 pi electrons. And if you calculate again the value of n from this equation, you will get it as integer. So it is following the Huckel's rule. What is the value of n that you will get? It is obviously 1. Now, your benzene has a possibility of doing substitution in its hydrogen. You can remove a hydrogen from here or from here or from here, and that results in 3 isomeric substitution products: ortho, para, and meta. Then, when do we come to know that there is a delocalization? Because the carbon-carbon length, bond length, is equals to 139 picometer. Now, this bond length that you are seeing, it is neither equals to the single bond nor equals to the double bond. Instead of that, it is greater than the single bond. Sorry, it is lesser than the single bond and greater than the double bond. Means it is intermediate. Therefore, we concluded that your bond character is neither single and nor double. And this can only happen due to the delocalization of electron. Okay. So 6 pi electrons are being delocalized over the entire ring to give you the benzene ring. Now moving on to the general preparation. First of all, decarboxylation. We have seen this reaction. We are again taking a sodium salt. In this case, we are taking a sodium salt of benzoic acid, known as sodium benzoate. We treat it with the hot soda lime to get the corresponding benzene with the removal of the Na2CO3. Next, if you treat your benzene diazonium chloride, which is containing N2 plus Cl minus attached to the benzene, then it can be converted to benzene by directly treating it with water or with a dehydrating agent such as H3PO2. Next, we have dehydroxylation, in which your hydroxy group is removed from the benzene, creating a normal benzene. This is done with the help of zinc dust. See, your phenol treated with zinc in the presence of heat is giving you the benzene. Then, talking about the reactions of benzene, so we have multiple reactions possible for benzene. First one is known as the electrophilic aromatic substitution, in which we treat our benzene with certain electrophiles which can be generated under certain conditions. First one, if you treat your chlorine with anhydrous Cl3, it will create Cl plus, which can be added to this benzene, forming the chlorobenzene. Second one, here we take the sulfonating mixture, right, and treat it with benzene to get the benzene sulfonic acid, and the electrophile is known as SO3, sulfur trioxide. Next, then we have nitrating mixture, which is a combination of HNO3 and H2SO4. Treating it with benzene gives you a nitrobenzene, and the electrophile is NO2 plus. After that, we have Friedel-Crafts alkylation and acylation. In both of these cases, the mechanism is almost same, only the reagent is different. Means in the first case, we are adding a alkyl group which is CH3. In the second case, we are adding a COCH3 group creating a acetophenol. Got it? In the first case, the electrophile is CH3 plus, and the second case the electrophile is CH3CO plus. Moving on to the next type of chemical reaction known as addition reaction. So here what we do is we add hydrogen to the benzene using the nickel catalyst under elevated temperature by heating it to create the normal cyclic compound which is non-aromatic in nature. This is your cyclohexane. So we are doing a kind of hydrogenation. Or you can also add chlorine onto the benzene by treating it with the chlorine molecule in the presence of UV light. See, here is the reaction. If we take 3 molecules of chlorine, then 6 chlorines will be added across the benzene to create the benzene hexachloride or BHC. And this thing is done under elevated temperature, which is 500 Kelvin. So this was all about the theory part. So we'll do some questions on it. Just wait for a while. So here is the first question. But1 may be converted to butane with reaction by first is ZnHCl, SnHCl, ZnHg or P2H2. So we have talked a lot about this. You can do the reduction of your alkene with the help of H2 in the presence of catalysts such as platinum, palladium or your nickel. So in that perspective, your correct answer would be option D, which is palladium H2. It's very simple. If you treat your but1 with palladium H2, then it will result in the hydrogenation and conversion of but1 to butane. So this is your corresponding reaction. It's a very simple one. Moving on to the next question. We have a mixture of ethyl iodide and N-propyl iodide. This is subjected to Wurtz reaction. Remember, we are using a mixture of two alkyl halides. So what will be the hydrocarbon? That will not be formed. So try to combine first of all the similar type of molecule and the different type of molecule. You will get 3 different type of alkanes and one will not be formed. So options are butane, propane, pentane and hexane. What will be the correct answer? So ethyl and propyl means 2 and 3. So first of all, 2 plus 2 means from the same molecule will give you a carbon chain of length 4. So that is butane. Then again propyl it will be 3 and 3. That will give you hexane. Then the two different can combine with each other means 2 and 3. 2 for ethyl and 3 for propyl. That will give you pentane. So it is very clear that the B option is the correct one. So answer would be B, which is propane. So in Wood's reaction, if you combine two molecules together, then it will result in the removal of NaX. And the three options that are possible, the first is your ethyl iodide reacting with another molecule of ethyl iodide to give you the butane. Then next, your two molecules of propyl iodide can couple together to form the hexane. And lastly, two different molecules, ethyl iodide and the N-propyl iodide given in the question, can couple together to form the pentane. So propane is something which is not possible in the Wood's reaction of your ethyl iodide and N-propyl iodide. Therefore, this reaction is not preferred for the preparation of normal alkanes because it is giving you a mixture of product like butane, hexane and pentane in the same reaction mixture, because it contains, because the required product is of odd count of carbon. Next, pure methane can be produced by, questions are options are Wood's reaction, Kolbe's electrolytic method, soda lime decarboxylation and reduction with H2. How do you rationalize this question? So it's a very fantastic question because you have to first rationalize each option. First one, Wood's reaction. In Wood's reaction, we always see a coupling. So you have to couple at least one carbon together to form a carbon chain length of 2. So that is something which will not give you a product. Then what about Kolbe electrolytic method? Here also, you must have remembered that in Kolbe's electrolytic method, even number of carbon is seen in the product alkane, and even means starting from 2 itself. So to produce methane is not possible in this reaction. Then after, if I move on to the option number C, then here is the possibility of creating methane, because if you take acetate ion, which is sodium salt of your acetic acid, then in that case, if you treat it with the hot soda lime, then it would result in your methane. Next is your reduction with H2. Again, if you are reducing it with H2, that means you are treating it with an alkene. And alkene is only possible when you have at least 2 carbon. Got it? Therefore, the correct option would be option C. So pure methane can only be produced from soda lime decarboxylation, and here is the reaction that, as I said earlier, you will start with the sodium salt of carboxylic acid known as sodium acetate and treat it with NaOH and CaO in heating condition to give you the methane and Na2CO3. Next, question number 4. Which of the following has the minimum boiling point? We have 4 options here: N-butane, 1-butyne, 1-butane and isobutane. Now all of them have the same molecular mass because all have a word root of but, which is equals to 4 carbon. Now the question is that which is one is having the highest branching in it. Okay, so we have butane, you have butyne, you have butane and you have isobutane. How you will decide it? One more factor is still there, which is the presence of butyne and butene. Is there a chance that you will have butyne and butene having minimum boiling point? No, it's not possible at all. It can have a higher boiling point because it has polarity in it due to higher electronegative carbon atom, which is sp or sp2 in nature. Got it? So the only possibility that we are left with it is the isobutene, which has higher branching as compared to other alkane, alkene or alkyne. Since it has higher branching, so it will have less surface area and hence less amount of or less strength of van der Waals force. Therefore, the correct answer would be option D, which says that isobutene has minimum force of attraction due to steric hindrance and that will create minimum boiling point. Our next question, you have to arrange the given in the decreasing order of their boiling point. All of them are alkane, and how you will differentiate them? It's very simple. You have to just see that which one of them has the highest molecular mass, and if the molecular mass is same, in that case you will compare their branching. We start from butane, normal butane, then you have 2-methyl butane, meaning that you have 5 carbon in total, one for the but and one for the methyl. Next one is pentane, means 5 carbon atom. Again same thing, in B and C have the same number of carbon atom. Then in D we have 2,2-dimethyl propane. So first we have a chain length of 3 carbon and 2 carbon attached to it. in the form of methyl. So total of 5 carbons. So B, C and D have the same number of carbon atom, whereas A has the least number of carbon atom. Due to the highest number of branching in D, it will have a least boiling point. Okay. So it will have the least boiling point, but not less than the N-butane, because N-butane has lower number of carbon. Got it? So this N-butane will have the least boiling point among the four, and 2,2-dimethyl propane will have the least boiling point among B, C and D. Now that would make very clear the answer would be option D. So the carbon chain increases its boiling point along with the increasing molecular mass. In case we have seen there are cases of similar molecular mass, so we will decide the boiling point with the help of branching. So in the four options, butane has the lowest molecular mass, so it will have the lowest boiling point. Then comes your N-pentane because it has highest molecular mass and least branching. Then below that, sorry, in between that, what will be there? So first of all, we will have the highest one, the second highest one as 2-methyl butane because it has less branching as compared to 2,2-dimethyl propane and more branching as compared to pentane. Then we have in the second last as 2,2-dimethyl propane. Got it? So the correct option is C, B, D and A. Then our next question, you have to decide the percentage of 1-chloro-2-methyl propane obtained in the chlorination of isobutane. So I am leaving this question on to you since we are lagging time. This was all for today's class. Thank you for joining the session. I hope you enjoyed it.
Hello everyone. Today we'll cover straight line. Okay. So at first we will know what is concept behind the straight line. Okay. Then after that we'll move on a different form of equation of line, and then we will discuss how we can calculate angle between two lines. Okay. After that we will discuss what is the condition for the concurrence of three lines and what is the meaning of concurrence of three line. Okay. And how we can calculate distance of a point from a line. So if we have a line and we are given a point and ask for what is the distance between this point and this line, then what is the formula to calculate this distance, and what is that specific distance. Okay. After that we will look at some important result. Then what is equation of internal and external bisector of angle between these two lines, and equation of family of lines through the intersection of two given lines. And after that we will discuss some important properties of straight line. Okay, so let's start. So what is a straight line? When a curve is called straight line. Let's suppose we have a curve and let we have 2 points from that curve. We just take 2 points from the curve. If each and every point on the line segment joining these 2 points lies on the curve, then that curve is called straight line. Clear? We have a curve, and if we take any 2 point from the curve and if we join the both point, we get a line segment, and if all the points from the line segment lie on the curve, then that curve is called straight line. Clear? And how we can calculate the slope of this line, slope of a line? So we have a line AB. Okay, so according to the definition of a straight line, if we take any point from this line AB, then the line segment that we join by this 2 point also lie on the line. Clear? And how we can calculate the slope, the steepness of line? So this, if we have 2 point from the line, then by using that 2 point we can calculate the slope. So let's suppose we have 2 point A x1 y1 and B x2 y2 on the line, then its slope is given by, that is noted by m, is equal to y2 minus y1 by x2 minus x1. And in terms of 10, so let's suppose the line makes an angle theta with positive direction of x-axis, then the slope is given by m is equal to tan theta. Clear? So slope is equal to m is equal to tan theta, and in terms of points is equal to y2 minus y1 by x2 minus x1. Clear? So now we'll discuss various form of equation of line. So at first, what is the general form of an equation of a line? So general form of equation line is ax plus by plus c is equal to 0. Here a is coefficient of x, b is coefficient of y, and c is constant term. So this is the general form of equation of a line, and there is various form to represent an equation of a line. The first form is slope intercept form. So as its name suggests, the equation of a line is given by the slope of a line and intercept. Okay, So let's suppose we have a line and the slope of that line is m, and the line making intercept C on y. So this line makes an intercept C on the y-axis. Then its equation in slope intercept form, that means by using the slope and its intercept, is given by y is equal to mx plus c. So this is the equation of a line by using its slope and y-intercept. Here y is equal to mx plus c, m is the slope of line and c is the y-intercept. Okay. Next form is point slope form. So let's suppose we have a line and one point x1 y1 through which the line is passes. Okay, so we have to find the equation of line that passes through this point x1 y1 and has a slope m. Then equation of this line is given by y minus y1 is equal to m into x minus x1. Clear? So this is point slope form. According to the name, it uses a point from the line and the slope of the line to write the equation of that line. Clear? Next form is 2-point form. So here is a straight line as we can see in the figure, and we have to write the equation of this line. Okay, so we have 2 points x1 y1 and x2 y2 through which this line is passing. Okay, so we have to find the equation of line which passes through the point x1 y1 and x2 y2. Clear? Then the equation of line is y minus y1 is equal to y2 minus y1 by x2 minus x1 into x minus x1. Clear? Here y2 minus y1 by x2 minus x1 is the definition of slope, formula for slope. So this is nothing but point and slope form where we write the slope in terms of the points. That is, so we get y minus y1 is equal to y2 minus y1 by x2 minus x1 into x minus x1. Clear? Next is intercept form of a line. So how we can write equation of a line using its intercept? So let's suppose we have a line L as in figure, and it make A intercept on x-axis and B intercept on y-axis. That means the line cuts the x-axis at a point a comma 0, there y coordinate is 0, and it cuts the y-axis at a point 0 comma b. Clear? So x-intercept is a and y-intercept is b. Then we can write the equation of this line as x by a plus y by b is equal to 1, where a is x-intercept and y is b-intercept, and b-intercept is y, intercept on y-axis. Clear? So this is the intercept form of a line. Clear? Next is normal or perpendicular form. Okay, so let's suppose we have a line capital L and the equation of the straight line upon which the length of perpendicular from the origin is L. So what is L? L is we draw a perpendicular from the origin to the line. So the OP is perpendicular to line L and the distance OP is small l. Okay, so we have the distance L, and there is also one more information that this perpendicular makes an angle alpha with positive direction of x-axis. So we draw a perpendicular from origin to that line, and the distance of origin to the line is small l, and this perpendicular makes an angle alpha with positive direction of x-axis in anticlockwise sense. Then equation of this line is given by x cos alpha plus y sin alpha is equal to p. where your alpha lies between 0 to 2 pi. Okay, so we can write our equation of a line by just using the distance of a line from the origin, that perpendicular distance, that is L, and the angle which it makes with x axis. Clear? Next form is general equation of line to the normal form. So if we have general equation of a line, what is the general equation of line? That is ax plus by plus c is equal to 0. Okay, and now we want the normal form from this general form. So we want to convert this general equation of a line into the normal form. Okay, so how we can convert it? So first step, to convert the general equation of a line to a normal form, at first write the constant term on the right hand side. So just shift the constant term on the right hand side and make it positive if it is negative. Okay, so we get ax plus by is equal to minus c, and if it is negative, then we make it positive by multiplying with negative. Okay, if it is not so, then divide both sides by root under coefficient of x whole square plus coefficient of y whole square. So first step is write the constant term on the right hand side. If it is negative, then make it positive, and then in a second step, divide both sides by root under coefficient of x whole square plus coefficient of y square. So in the general equation, what is coefficient of x? That is a. And what is coefficient of y? That is b. So we take c on the right hand side, so we get ax plus by is equal to minus c. Then we divide both sides by root under a square plus b square, so we get a by root under a square plus b square x plus b by root under a square plus b square y is equal to minus c by root under a square plus b square. Okay, and now take the first coefficient of x, that is a by root under a square plus b square, that is cos alpha. So cos alpha is equal to a by root under a square plus b square, and sin alpha is b by root under a square plus b square, and p is minus c by root under a square plus b square. So this is your required normal form. So that's how we can convert our general equation of a line, that is ax plus by plus c is equal to 0, into normal form of that line. Okay, clear? Next is intersection of lines. Okay, so we have two lines, a1x plus b1y plus c1 is equal to 0, and another line is a2x plus b2y plus c2 is equal to 0. Then their point of intersection is, now these two lines are intersecting at a point. So what is the coordinate of that point? So the coordinate of that point is, so we have two line a1x plus, as in figure, a1x plus b1y plus c1 is equal to 0, and another line is a2x plus b2y plus c2 is equal to 0. Okay, so let me have two lines, a1x plus b1y plus c1 is equal to 0, and a2x plus b2y plus c2 is equal to 0. So the point of intersection where they intersect, there is a point, and the coordinate of that point is given by this formula, that is b1c2 minus b2c1 by a1b2 minus a2b1, comma c1a2 minus c2a1 by a1b2 minus a2b1. Okay, that is the coordinate of xy. Next is distance form or parametric form. Okay. So the equation of the straight line passing through x1, y1 and making an angle theta with the positive direction of x-axis is. So how we can represent equation of line in parametric form? Another name is distance form. Okay. So if we have a straight line and that line is passing through x1 comma y1 and this line is making angle theta with positive direction of x-axis, then parametric form is x minus x1 by cos theta is equal to y minus y1 by sin theta is equal to r. Clear? Where this r is the distance of any point x comma y on the line from the point x1 comma y1. So this is your parametric form. So from the figure there is a line and A is a point x1 y1 and P is another any arbitrary point that is x comma y. So and the distance from A to P is r and theta is the angle that is made with positive direction of x-axis. So the parametric form is x minus x1 by cos theta is equal to y minus y1 by sin theta is equal to r. Okay. Next is angle between two lines. So we have two lines and then how we can calculate the angle between these two lines. Okay. So let's suppose we have two lines and the slope of first line is m1 and slope of second line is m2. So there is an acute angle that is theta between this two line. Okay. So this theta can be calculated by this formula that is tan theta is equal to mod m2 minus m1 by 1 plus m1 into m2. Okay. So by using slope of the lines we can calculate angle between these two lines by using this formula tan theta is equal to mod m2 minus m1 by 1 plus m1 into m2. Okay. So now look at the condition for parallel lines. So if two lines are given and suppose m1 and m2 are the slope of this two line, then these two lines are parallel only if the slopes of this both line are equal. That means if m1 is equal to m2, then these two lines are parallel. Okay. This is the condition for parallel lines. In terms of general equation, so if we have two lines and this both line is parallel, then its equation is in the form ax plus by plus c is equal to 0 and ax plus by plus lambda is equal to 0. So any line parallel to ax plus by plus c is equal to 0 can be taken as ax plus by plus lambda is equal to 0. The coefficient of x and y are same, only difference with in constant term. First equation is ax plus by plus c is equal to 0 and line parallel to this equation is ax plus by plus lambda is equal to 0. Clear? Now what about perpendicular lines? So let's suppose we have two lines as in figure, line L1 and line L2. The slope of line 1 is m1 and slope of line 2 is m2 and these lines are perpendicular. That means the angle between these two lines is 90 degree. Then what is the condition for perpendicular lines in terms of slope? So as m1 is slope of line 1 and m2 is slope of line 2, then these lines are perpendicular if the product of their slope is equal to -1. Okay, that means m1 into m2 is equal to -1. Then these lines are perpendicular. Okay. One important thing, so if a line is parallel to x-axis, then clearly it is perpendicular to y-axis. So one line is parallel to x-axis, so just take a line that is parallel to x-axis, then its perpendicular line is parallel to y-axis. So if you take a line that is parallel to x-axis, then that line is perpendicular to y-axis. And if you take the perpendicular line to that line, then that line is parallel to y-axis. Clear? You can clearly observe this by drawing the figure on Cartesian system. Next is the equation of the line perpendicular to, there is a general form. So we have a given equation in a general form, that is ax plus by plus c is equal to 0. So any line that is perpendicular to this line, then equation of that line is taken as bx minus ay plus lambda is equal to 0. Clear? And if we have two straight line, that is ax plus by plus c is equal to 0 and a dash x plus b dash y plus c dash is equal to 0, then these two lines are in right angle. Angle between these two lines is 90 degree if a into a dash plus b into b dash is equal to 0. Okay. Now, what is concurrence of three lines? So let's suppose we are given three lines. So when these three lines passes through the same point, then they are called concurrent. Okay, three lines are said to be concurrent if they passes through a common point. They meet at a point. Okay, so we have three lines as in figure L, M and N, and this all three lines are intersecting at a same point, common point, that is O. So these three lines are concurrent. Okay, so if three lines are concurrent, then the point of intersection of two lines lies on the third line. So if you take any two line L and M, so where they intersecting, that intersecting point must lie on the third line. Okay, we can clearly observe this result from this figure. You take any two line, like you take M and N, so where this M and N intersecting, that point is O. So that intersecting point O must lie on the third line, that is L. Clear? And what is the condition for the concurrency? So let's suppose we have three lines, that and equation in general form is a1x plus b1y plus c1 is equal to 0. First line, and second line is a2x plus b2y plus c2 is equal to 0, and third line is a3x plus b3y plus c3 is equal to 0. Then these three lines are concurrent if determinant of the coefficients, first row is a1 b1 c1, coefficient of x, coefficient of y and constant term for line 1, and second row is a2 b2 c2, coefficient of x in second line, b2 coefficient of y in second line, c2 is constant term, and the third row is a3 b3 c3. So if we take its determinant and it becomes 0, then these three lines are concurrent. Okay, and this is your required condition for concurrence of three lines. So if you are given a three lines in a general form, so to check this line are concurrent or not, we have to check is it the determinant is 0 or not. Okay, okay, so next topic is distance of a point from a line. So we are given a line and a point. Okay, so the line is ax plus by plus c is equal to 0, and coordinate of points is x1 comma y1. So what to do we need what do we need to do? Basically, we have to find the distance of a point from the line, that is x1 y1, to the line ax plus by plus c is equal to 0, and that distance is the perpendicular distance. So we just draw the perpendicular line from the point x1 y1 to the line ax plus by plus c is equal to 0 as in figure. So there is a point P, that is x1 comma y1, and the line ax plus by plus c is equal to 0, and we have to find the distance of a point from the line. So we draw a perpendicular to the line, and that perpendicular distance, just say d, So how we can calculate this D? So this D is given by the formula mod ax1 plus by1 plus c by root under a square plus b square. Okay. And if you are given two parallel lines, like the first line is ax plus by plus c1 is equal to 0, and another line is, as this both line is parallel, it means the coefficient of x and coefficient of y is same. So another line is ax plus by plus c2 is equal to 0. The only difference between these two general form of parallel lines is the constant term. In the first this is c1 and in the second is c2. So the distance between these two parallel line is given by this formula, that is mod c2 minus c1 by root under a square plus b square. Clear? So in case of point and line, the formula is mod ax1 plus by1 plus c by root under a square plus b square. And in case of two parallel lines, this formula is given by mod c2 minus c1 by root under a square plus b square. In both cases, we take the perpendicular distance. We draw a perpendicular and then we find the distance, that perpendicular distance. Okay. Okay, so some important result. So if we need to find the foot of perpendicular HK from x1 y1 to the line ax plus by plus c is equal to 0. So we have a line ax plus by plus c is equal to 0 and one point x1 y1, and we draw a perpendicular from the point x1 y1 to the line ax plus by plus c is equal to 0. So we have to find the foot of perpendicular, that is HK. So that is given by h minus x1 by a is equal to k minus y1 by b is equal to minus ax1 plus by1 plus c by root under a square plus b square. Clear? So here h and k are basically the foot of the perpendicular that fails from x1 y1 onto the line. Okay. So foot of perpendicular from AB on x minus y is equal to 0. So if you take a particular line and that line is x minus y is equal to 0, that means the line where x is equal to y. Then from any point A to B, if you draw a perpendicular to that line x minus y is equal to 0, then the foot of perpendicular is given by, coordinate of the foot of perpendicular is a plus b by 2 comma a plus b by 2. Particular case, another sorry, if the equation of line is x plus y is equal to 0 and we draw a perpendicular from point a comma b to that line, then the foot of perpendicular in this case is given by a minus b by 2 comma b minus a by 2. Clear? Here the line is y is equal to minus x. Clear? Because x plus y is equal to 0. Another thing, now we want to find image of a point if we take a line as mirror. So we have a straight line, that is ax plus by plus c is equal to 0, and we consider this line as a mirror, and we want to find the image of a point x1 comma y1 if this line act as a mirror. So the image, we take the coordinate of image as h comma k, then that can be found by this formula h minus x1 by a is equal to k minus y1 by b is equal to minus 2 ax1 plus by1 plus c by a square plus b square. So this means using this formula we can find the position of the image, okay, if our line behaves like a mirror. Okay. Now area of parallelogram formed by this by the lines. So if these lines formed a parallelogram and lines are a1x plus by b1y plus c1 is equal to 0, first line, a2x plus b2y plus c2 is equal to 0, your second line, and a1x plus b1y plus d1 is equal to 0 and a2x plus b2y plus d2 is equal to 0. So if you observe the first equation, that is a1x plus b1y plus c1 is equal to 0, and the third equation, that is a1x plus b1y plus d1 is equal to 0, both lines are parallel because the coefficient of x and y is same in both lines, and the same in the second equation and the fourth equation of line. This both two lines is parallel, so these lines made a parallelogram, and the area of that parallelogram is given by the formula mod d1 minus c1 d2 minus c2 by a1 b2 minus a2 b1. Clear? Next topic is equation of internal and external bisector of angles between two lines. So we have two lines. First line is a1x plus b1y plus c1 is equal to 0 as in figure, and second line is a2x plus b2y plus c2 is equal to 0, and these lines are intersecting lines, so they made an angle between them. So we have to find the internal and external bisectors. Equation of internal and external bisector. So the bisector of angles between these two straight line are the locus of point which is equidistant from the two lines. Okay, so we find the locus of the point which are equidistant from the two lines. Okay, so the equation of bisector of angle between this line is given by so a1x plus b1y plus c1 by root under a1 square plus b1 square is equal to plus minus a2x plus b2y plus c2 by root under a2 square plus b2 square. So this is the equation of bisector of the angle between the lines. Okay, where if a1 a2 plus b1 b2 is greater than 0, then the positive sign, there is two sign in the equation, plus and minus sign. Then if this condition satisfied, that is a1 a2 plus b1 b2 greater than 0, then with the positive sign is the equation for bisector for obtuse, and the negative sign for acute. Okay, and in case if a1 a2 plus b1 b2 less than 0, then negative sign for obtuse and positive sign for acute. Okay, so now what is the equation of the family of line passing through the intersection of the lines? So we have two lines, a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0, and we have to find the equation of all those lines that passes through the intersection point of these two lines, and that is given by a1x plus b1y plus c1 plus lambda a2x plus b2y plus c2 is equal to 0. So this is the equation of family of lines that is passing through the intersection of these two lines. Okay, where lambda is a parameter. Some properties, some important properties. So the position of point, let's suppose we have 2 point x1 y1 and x2 y2 and one line ax plus by plus c is equal to 0, and we want to find the position of this both point relative to the line. So first one, if ax1 plus by1 plus c by ax2 plus by2 plus c is greater than 0, then these points lie on the same side. So if this condition satisfy, then P and Q, the first point is P, x1, y1, and second point Q, that is x2, y2, lie on the same side of the line. And if ax1 plus by1 plus c by ax2 plus by2 plus c is less than 0, then these points lie on the opposite sides. If P lie on this side, then Q is on the opposite side. Clear? Next property, the equation of the straight line which passes through a given point x1, y1 and make an angle alpha with the given straight line y is equal to mx plus c. So now we find the equation of a straight line. So this line is passes through x1, y1 and this line make an angle alpha with the straight line y is equal to mx plus c. Then the equation of line is given by y minus y1 is equal to m plus minus tan alpha by 1 minus plus tan alpha x minus x1. Clear? So these are the all formula related to straight lines. Okay, clear? So just wait for a moment. Now we'll practice some question. Okay, so first question is the equation of the line, the reciprocal of whose intercept on the axis are A and B is given by. So in this question, we have to find equation of a line. And what is the condition? The reciprocals of whose intercept? If we take the reciprocal, if we take the intercept of the line as A1 and B1, then if we take the reciprocal of A1 and B1, then that is equal to A and B. Then what is the equation of line? Option A, x by a plus y by b is equal to 1. Option B, ax plus by is equal to 1. Option C, ax plus by is equal to ab. And option D, ax minus by is equal to 1. Okay, so try this question. Use the intercept form to find the equation of line. And as there is a condition that reciprocal of whose intercept, so if you take a1 and b1 as intercept of the required line, then that is reciprocal of a and b. So just use this simple information and use the intercept form to find the equation of line. So what do you think? Which option is correct? Anyone? Okay, let's solve. So correct answer is option B. Ax plus by is equal to 1. So the formula and the key points that we will use in this question are: first one is the intercept form of equation of a line, that is x by a plus y by b is equal to 1, where a and b are intercept of x and y axis. Okay, so let's suppose a1 and b1 are the intercept of the line on the axis, and as these are the reciprocals of a and b, so 1 by a1 is equal to a and 1 by b1 is equal to b. So from here we get a1 is equal to 1 by a and b1 is equal to 1 by b. So intercepts is 1 by a on x-axis and 1 by b on y-axis. So now we can write the equation of line by using intercept form, and that is x by a1 plus y by b1 is equal to 1. That means x by 1 by a plus y by 1 by b, and when we rearrange we get ax plus by is equal to 1. That is your correct answer. That is your required equation of the line. Clear? Question number 2. So in this question, the equation of the straight line passing through the point 4 comma 3 and making intercept on the coordinate axis whose sum is -1 is clear. So in this question we have to find equation of the straight line, and information is that line is passing through a point 4 comma 3, and also another information regarding its intercept is the sum of intercept is -1. So if you consider the intercept is a and b, then a plus b is -1, one information about the line, and another information is that line is passes through 4 comma 3. Okay, then we have to calculate the equation of the straight line. Options are: option a, x by 2 plus y by 3 is equal to -1; x by -2 plus y by 1 is equal to -1. Option B, x by 2 minus y by 3 is equal to -1. X by -2 plus y by 1 is equal to -1. Option C, x by 2 plus y by 3 is equal to 1. X by 2 plus y by 1 is equal to 1. And option D, x by 2 minus y by 3 is equal to 1, and x by -2 plus y by 1 is equal to 1. So as this option suggests, we use the intercept form. And what is the intercept form? If we know the intercept of a line, then by using the intercept we can write the equation of that line, that is x by a plus y by b is equal to 1. Clear? So at first try to figure out what is the intercept of this straight line by using the information that this line is passing through a point 4 comma 3 and the sum of intercept is -1, that is a plus b is -1. Okay, so try this question. We have to find the value of a and b to use the intercept form. Okay, and to find the intercept we have two equations. First, a plus b is -1, and another thing is that the line is passing through 4 comma 3. So this point must satisfy the equation of straight line. So use this information. So what is the value of a and b? Anyone? Okay, option D. Let's check. Correct answer is option D. X by 2 minus y by 3 is equal to 1 and x minus 2 plus y by 1 is equal to 1. Very good. So let's verify. So the formula that we use in this question, the first one is the intercept form of equation, that is x by a plus y by b is equal to 1, where a and b are the intercept of x and y axis. Okay. So let the x-intercept as A and y-intercept as B. So according to the question, the sum of these intercept is -1. So A plus B is -1. So from here we get B is equal to minus A plus 1. And so equation of line is in intercept form is x by A minus y by A plus 1 is equal to 1, as x-intercept is A and y-intercept B, that is minus A plus 1. So we get this. Now another information in the question is that the line is passing through the point 4 comma 3. So equation must satisfy this point. So just substitute 4 and 3 in place of x and y. So we get 4 by a minus 3 by a plus 1 is equal to 1. Simplify this. To find the value of a, we get 4a plus 4 minus 3a by a into a plus 1 is equal to 1. So we get a plus 4 is equal to a square plus a, which gives a is equal to plus minus 2. So we get two value. A is equal to plus 2 and a is equal to minus 2. And for this value, we also calculate the value of b. So the equation of line, when a is equal to 2, we get b is equal to minus 3. So equation of line intercept form is x by 2 minus y by 3 is equal to 1. And when a is minus 2, we get y intercept as 1. So we get x by minus 2 plus y by 1 is equal to 1. Clear? Next question. The equation of a line passing through minus 4 comma 3 and the points divide the portion of line between x's in the ratio 5 is to 3 internally. Then what is the equation? Options: 9x plus 20y plus 96 is equal to 0. Option B: 20x plus 9y plus 90x is equal to 0. Option C: 9x minus 20y plus 96 is equal to 0. And option D: 20x minus 9y minus 96 is equal to 0. So try this question. So in this question, we need to find equation of that straight line which passes through minus 4 comma 3, and this point 4 comma 3 divide the portion of the line between the x's internally in the ratio 5 is to 3. Okay. So to find the equation of line, we have to use the section formula. Okay. So how we can apply the section formula? Just think and solve. We can also find this point minus 4 comma 3 by using the section formula, because this point divide that portion of line between x's in the ratio 5 is to 3. And as this portion lies between the x's, so what is the point of intersection on the axis? When we intersect the x-axis, the point must be of the type a comma 0 type, and on the y-axis where they intersect, that point is of the type 0 comma b. So these are the 2 point. Okay. So which option is correct? Varsha? Okay, let's solve. So correct answer is option C, that is 9x minus 20y plus 96 is equal to 0. So in this question, we use section formula. So that is x is equal to mx2 plus nx1 by m plus n, and y coordinate is equal to my2 plus ny1 by m plus n. So if any point divide the line in the ratio m is to n, then that point is given by this. And what is the intercept form of equation of line? That is x by a plus y by b is equal to 1. Okay. So let the equation of line is x by a plus y by b is equal to 1. So we have to find a and b to find the required equation. Okay. So according to the given condition, the point C minus 4 comma 3 divide the portion of the line between x's in the ratio 5 is to 3. Okay. As in this figure, so this point divide the ratio 5 is to 3, and the point is a comma 0 and 0 comma b. So we can calculate this point minus 4 comma 3 by using section formula. So we get c minus 4 comma 3 is equal to c 3a by 8 comma 5b by 8. So 3a by 8 is equal to minus 4 and 5b by 8 is equal to 3. So from here we can calculate the value of a and b. So a is equal to minus 32 by 3 and b is equal to 24 by 5. So now we have the value of intercept. So we can use the intercept form to find the equation of line. So we get minus 3x by 32 plus 5y by 24 is equal to 1. So when we simplify it, we get minus 9x plus 20y minus 96 is equal to 0. That is 9x minus 20y plus 96 is equal to 0. Okay. Next question. A straight line through a fixed point 2 comma 3 intersect the coordinate axis at distinct point P and Q. Okay. If O is the origin and the rectangle OPRQ is completed, then the locus of R is options 3x plus 2y is equal to 6, 2x plus 3y is equal to xy, 3x plus 2y is equal to xy, and 3x plus 2y is equal to 6xy. Okay, so try this question. Take the point as h comma k. Okay, so we have to find an equation for point R. Okay, let's solve together. So correct answer is option C, that is 3x plus 2y is equal to xy. The formula and key point that we use in this question is, first is section formula, that is x equal to mx2 plus nx1 by m plus n, and y coordinate is given by my2 plus ny1 by m plus n. And second is intercept form of equation of line, that is x by a plus y by b is equal to 1. So we have to find locus of R and straight line through a fixed point 2 comma 3 that intersect the coordinate axis at P and Q. So as they intersect on, so when we intersect the x-axis, so that point P is given by h comma 0, and this line intersect on the y-axis at a point Q, that is 0 comma k. So what is coordinate of R? That is h comma k. So we have to find the locus of R. Okay, and since it is passes to the point 2 comma 3, so if you take the equation of line as x by a plus y by b is equal to 1, then intercept form is x by h plus y by k is equal to 1, as the intercept are h and k. So now as this line is passing through a point 2 comma 3, so this point is also satisfy the equation. So we can substitute 2 and 3 in place of x and y. So we get 2 by h plus 3 by k is equal to 1. So from here we get 2k plus 3h is equal to hk. So now we just need to replace k and h by x and y. So we get, in place of h we write x, and in place of k we write y. So we get an equation that is locus of R, that is 3x plus 2y is equal to xy. Okay. Next question is, if the x-intercept of some line L is double as that of line 3x plus 4y is equal to 12, and the y-intercept of L is half as that of the same line, then the slope of L is. Okay, so we have to find the slope of line L. And what is the given information? First, the x-intercept of this line is double as the line 3x plus 4y is equal to 12. Okay, so at first we have to find the x-intercept for the line 3x plus 4y is equal to 12, and also the y-intercept of this line, as the y-intercept of line L is half as the line y-intercept of the line 3x plus 4y is equal to 12, and then we find the slope of line L. Okay, options are -3, option B -3 by 8, option C -3 by 2, and option D -3 by 16. Okay, so let's solve. Correct answer is option D, that is -3 by 16. How we get this? So the formula we use, first is intercept form, that is x by a plus y by b is equal to 1, and slope, that is gradient. So gradient is equal to minus of coefficient of x by coefficient of y. Okay, so given line is 3x plus 4y is equal to 12. So if we convert this line, the general form, to a intercept form, we divide both sides by 12. So we get x by 4 plus y by 3 is equal to 1. So this is the intercept form of the line 3x plus 4y is equal to 12. So here x-intercept is 4 and y-intercept is 3. So according to the question, for the required line, x-intercept is double as the intercept of this line. So we get 2 into 4, that is 8. And y-intercept is half of this line. So 1 by 2 into 3, that is 3 by 2. So x-intercept is 8 and y-intercept is 3 by 2. So equation of line L is x by 8 plus y by 3 by 2 is equal to 1. Now to find gradient, we need coefficient of x and coefficient of y. So convert this line, this form, this intercept form into a general form, and find the coefficient of x and coefficient of y. And when you divide and take a negative sign, we get the slope, that is m is equal to -3 by 16. Clear? Next question is, for what values of a and b intercept on axis by line ax plus by plus 8 is equal to 0 are equal and opposite is in sign of intercept on axis by the line 2x minus 3y plus 6 is equal to 0. So in this question we have to find the value of a and b, that is value of the intercept for the line ax plus by plus 8 is equal to 0, and there is a relation with the intercept of the line 2x minus 3y plus is equal to 0, and that relation is defined as that the intercept are equal and opposite in sign of intercept of this line. Okay, so we just use that relation. At first find the intercept for the line 2x minus 3y plus 6 is equal to 0, and then use this relation to find the value of a and b. So options are option A, that is 8 by 3, Option B, option A is the value of A is 8 by 3 and B is minus 4. And option B, the value of A is minus 8 by 3 and B is minus 4. Option C, the value of A is 8 by 3 and B is 4. And option D, A is minus 8 by 3 and B is 4. Okay. So take this question as a homework and try to solve. Okay. So that's all for today. I hope this session was helpful. Okay. So try this question. Take it as homework. Okay. Thank you.
Hello students, in today's lecture we are going to learn about electromagnetic induction and this is theory part. This is our disclaimer. So let's see trend analysis of the chapter electromagnetic induction uh, according to last 5 years. So overall weightage is to 4.24%. Alright, this makes it a moderately important reliable chapter to study. Alright, if we talk about yearly question distribution, so we can say in 2024 question asked from Faraday's law and inductance. Number of questions 2. And if we talk about their difficulty level, so we can say question was average. Similarly, in 2023, question asked from Faraday's law. Number of questions 1. And if we talk about their difficulty level, so we can say question was easy. In 2022, question asked from magnetic flux and Faraday's law. Similarly, in 2020, question asked from magnetic flux, Faraday's law, and their difficulty level average. All right. So from this data, we can say Faraday's law is a very important concept for the exam. All right. So in today's lecture, we will discuss first electromagnetic induction, then magnetic flux, then Faraday's law of electromagnetic induction, then we will discuss Lenz's law, then we will discuss motional EMF. After that, we will discuss motional EMF in a loop. Then we will discuss rotational EMF. Then self-induction. After that, we will discuss self-inductance. Then we will discuss magnetic potential energy of an inductor. Then we will talk about the formula for self-inductance. After that, we will talk about the mutual induction. Then mutual inductance. Then we will talk about the formula for mutual inductance. Then we will study combination of inductors. And last, we will see eddy currents. So these are the topics of the today's lecture, which we will discuss one by one. All right, students, clear? If yes, write in the chat box. So students, our first concept is magnetic flux. Magnetic flux, just like a electric flux. Magnetic flux is defined in a similar way. The basic idea behind both is to measure how many field lines pass through a given surface. Okay, magnetic flux denoted by symbol phi b. Phi b measures how many magnetic field lines are passing through a surface. For a uniform magnetic field B, the flux passing through a plane surface A can be written as phi b equal to B dot A. So when we solving dot product, you will get BA cos theta. Alright. So as shown in the figure, look at here in the figure. For a uniform magnetic field, the magnetic flux passing through a plane of area A, okay, is calculated the dot product or we can say the scalar product of magnetic field vector B and the area vector A. Okay, so we know the formula, that is phi b equal to B dot A. So it will be BA cos theta. All right. In this formula, B is the magnitude of the magnetic field. Okay, A is the magnitude of the area. And what is theta? Think about it. Theta is the angle between the magnetic field vector B and the area vector A. Okay, the area vector is always perpendicular to the surface. Look at here, always perpendicular to the surface. Perpendicular means normal. All right. If we talk about the quantity, so we can say magnetic flux is a scalar quantity. It has magnitude but no direction. In physics, outward magnetic flux is considered positive, that is theta should be less than 90 degree, and whereas inward magnetic flux is considered negative, that is theta should be greater than 90 degree. Okay. If we talk about the SI unit of magnetic flux, so we can say SI unit of magnetic flux is Weber. Okay, it is also called Tesla meter squared, and there is a relation between Weber and Tesla meter square, that is 1 Weber equal to 1 Tesla meter square, and this is very important for the exam. And if we talk about the dimensional formula of magnetic flux, so we can say m I square t raised to the power minus 2 A inverse. Okay, so this is the dimensional formula of magnetic flux. Now our next concept is Faraday's law of electromagnetic induction. This is very important concept for the exam. Okay, almost, or we can say all the questions from this chapter are based on Faraday's law of electromagnetic induction in JEE main exam. Let's see. Faraday's law of electromagnetic induction, or we can say law of electromagnetic induction, states that when the magnetic flux through a circuit such a coil changes, an induced electromotive force, or we can say EMF or voltage is created in it. Okay, and what is here magnetic flux? Magnetic flux is a measure of magnetic field lines. Okay, so let's look at the mathematical form of induced EMF. So induced EMF denoted by E, which is equal to minus d phi b upon dt. Okay, phi b we know that is magnetic flux, and d phi b upon dt is rate of change of magnetic flux. All right. And if we talk about the absolute value, so it will be mod of E equal to d phi b upon dt. Here the important concept, the minus sign. What is that? The minus sign merely indicates that the direction of induced EMF and the current generated by it is opposite to the change occurring in the magnetic flux. Okay. When suppose when a coil has more than one turn, okay, then we consider as we consider n turns, or we can say n as the total number of turns. Okay, so when the coil is closely bound, the magnetic flux passing through each turn is almost the same. So let's see, for n turns, the induced EMF, or we can say total induced EMF, is equal to minus n d phi b upon dt. And we know what is d phi b upon dt? Rate of change of magnetic flux. Yes or no? So we know we absolute value is mod of E equal to n into d phi b upon dt. When the magnetic flux phi b associated with a circuit coil, or you can say circuit, changes, an induced EMF is generated in it. Okay, so when a coil has n turns, the total induced EMF is the sum of the EMF of all these turns, which makes the total induced EMF n times greater. All right, so this formula states that the value of the induced EMF depends on the rate of change of flux and number of turns in the coil. Clear, student? And this formula is a very important for solving numericals. All right. So increasing the number of turns n in a coil is an effective way to increase the induced EMF, and this is because according to Faraday's law of induction, the total induced EMF is the sum of the EMF of each turn. All right, and to find out the total induced EMF, we have the formula mod of E equal to n into d phi b upon dt. Clear? when we talk about the direction of induced EMF, okay, then from Faraday's law and Lenz's law, we derive this formula. So we have for n turns equal to minus n into d phi b upon dt. And students, think about it. What is the value of phi b? You know, phi b is the magnetic flux. So what is the formula to calculate the magnetic flux? Phi b equal to b dot a, and when we are solving dot product, you will be get ba cos theta. Yes or no? So we know phi b equal to ba cos theta. So just substitute the value of phi b in the in this relation, or in the relation of the induced EMF. So it become minus n d ba cos theta upon dt. Okay. So here uh, when we write here it differentiate it, you will be get minus nba cos theta 2 minus cos theta 1 upon delta t. All right. So whenever the magnetic flux phi changes in a closed electric circuit with a total resistance R, a current is induced in that circuit, and which is known as induced current. Okay. So here we have a formula for induced current, that is I equal to E upon R, which is equal to minus N upon R into d phi b upon dt. In this, E is the induced voltage, okay, R is the resistance of the coil, and capital N is the number of turns in the coil, right? And we know d phi b upon dt indicates how rapidly the magnetic flux phi b is changing. This means that if the magnetic flux changes quickly, a greater current will produced. Okay, greater current will be produced here. All right. So now from induced current, we know I equal to E upon R. We will talk about the formula for induced charge. So induced charge dq, which is equal to I dt. Okay. So we know the value of I, that is minus n upon R into d phi b upon dt. So just substitute the value here, and you will be get dq equal to minus n upon R d phi b. All right. This formula shows how much charge flowed in a time interval dt. The important point is that the total induced charge depends on the total change in magnetic flux, that is phi b, and not on its rate of change. Okay. If we talk about the induced power, so in that case its formula will be P equal to E square upon R, which is equal to N square upon R into d phi b upon dt whole square. And this formula, the formula of the power, look at here. The formula of the power indicates how much power was generated in the coil. Okay. This power depends on the induced EMF E and resistance R. Okay. And if we substitute the formula for induced EMF into this, it is found that power is directly proportional to the square of the rate of change of magnetic flux d phi b upon dt. This means that the faster the magnetic flux changes, the more power will be generated. Okay, clear? This is clear, students? Yes or no? Tell me. Yes or no? All right. Now let's see Lenz's law. This is very important principle. It simply means that whenever there is a charge in the magnetic field, okay, around a coil or wire, an induced current is produced, and the direction of that current is always such that it opposes the change that produced it. So according to Lenz's law, whenever there is a change in the magnetic flux in a coil, an induced current is produced. Okay, so the direction of this induced current is always such that it opposes the very change which produced it. Okay, so look at here, there are two poles, south pole and north pole. Yes or no? So for a north pole, denoted by N, the magnetic field is in the direction where the current flows anticlockwise. Okay, anticlockwise. And for a south pole, denoted by S, the magnetic field is in the direction where the current flows clockwise. Alright. So let's understand the direction in easy way. Okay. For the north pole, firstly we will understand for the north pole. Okay. When the north pole of a magnet approaches the coil, look at here. When the north pole of the coil approach, north pole of the magnet approaches the coil. Okay, like this. What happen? The magnetic flux in the coil increases. Okay, and to oppose this change, an induced current is generated in the coil, which makes the side of the coil closer to the magnet at a north pole. So north poles repel each other, which slows down the approach of the magnet. And for this, according to the right hand thumb rule, the current flows in anti-clockwise direction. Okay, clear, Ansh? And if we talk about the south pole, so for the south pole, when the south pole of a magnet is approaches the coil, look at here. When the south pole of the magnet uh, approaches the coil, in that case what happens? So think about it. When the south pole of a magnet approaches the coil, the magnetic flux increases. So to oppose this change, an induced current is generated in the coil, which makes the side of the coil closer to the magnet, a south pole. Okay, and south poles repel each other, which slows down the approach of the magnet. And for this, according to right hand thumb rule, the current flows in a clockwise direction. All right. Now we will discuss about the motional EMF. So what is motional EMF? So here we consider a rectangular setup, rectangular conductor setup. Look at here, PQRS. Okay, in which rod PQ is free to move. Okay, this entire system is placed in a uniform magnetic field B, which is perpendicular to the plane. Okay, so when the rod PQ moves to uh, moves to the left with moves to the left, okay, with constant velocity v, then the area of the loop changes. All right, so assume that the length of PQ and RS is L, as shown in the figure, and the length of PQ equal to RS is X. Then the magnetic flux linked with the coil phi B will be phi B equal to BLX. Okay, so as the rod moves to the left, the value of X decreases. Yes or no? which also cause the total magnetic flux to decrease. So according to Faraday's law of electromagnetic induction, when magnetic flux changes, an electromotive force known as EMF is induced in the circuit. Okay, so the magnitude of this induced EMF is equal to the rate of change of magnetic flux. So that is equal to minus d phi b upon dt, and we know the value of phi b, that is Blx. So just substitute the value of phi b, you will be get minus of d Blx upon dt. Okay, since b and l are constant, so we can write it as E equal to minus bl dx upon dt. And what is dx upon dt? Rate of change of position is what? Velocity. So it will be equal to blv. So here dx upon dt is equal to minus v, which is the speed of the conductor pq. Alright. Now the induced EMF that we calculated, VLB, is technically called motional EMF. Okay. From this concept, it becomes clear that electromagnetic induction does not occur in only one way. Alright. So Faraday laws of induction basically talks about the change in total magnetic flux. Clear? Now we will discuss motional EMF in a loop. So when a conducting rod moves on parallel rails, motional EMF E equal to BLV is induced in it. Okay, and the direction of the induced EMF is determined by the Fleming's right hand rule. So when there is a resistance R in the circuit, induced EMF flows, induced current flows. Okay, whose magnitude is mod of E equal to mod of E upon R. And what is E mod of E? VLV. So we can write mod of I equal to VLV upon R. Due to this current, a magnetic force Fm equal to B square L square V upon R acts on the rod in the opposite direction to the motion. Okay. Now let's see rotational EMF. Think about it. When a conducting rod of length L fixed at one of its ends rotates in a uniform magnetic field B with an angular velocity omega. Okay, uh, the plane of rotation is perpendicular to field. Then an induced EMF is set up between its ends. And the magnitude of this induced EMF is calculated by the formula, and the formula is mod of E equal to 1 by 2 B L square omega. Okay. Self induction. Self induction is a phenomena where an electromotive force or known as EMF is generated in a coil when the current flowing through it changes. Okay. So in this circuit shown in the figure, look at here, this one. When the switch K is closed, okay, the current starts to increase, causing a change in the magnetic flux linked with the coil. And this change in magnetic flux induced an EMF in the coil itself, which creates an induced current that opposes the increase in the original current. Conversely, when the switch K is opened, okay, the current decreases rapidly, which again changes the magnetic flux. And this change induces an EMF that arises to maintain the current flow by producing an induced current in the opposite direction. Alright, so the Induced EMF always acts to resist any change in the current flowing through the coil. If we talk about the mathematically, so we can say the induced EMF is proportional to the rate of change of current and given by E equal to minus L di upon dt. L is what? L is the self inductance of the coil. Alright. And in the figure here RH resistor, okay, in the circuit controls the current, and ammeter A measures the current flowing through the coil. This entire process is what we call self induction. Inductance, next is inductance. Inductance is an inherent property of every electrical circuit. Okay, it is also called the electrical inertia of circuits. Just as mass opposes a change in physical motion, similarly, inductance opposes a change in current in a circuit. Okay, and this property indicates how effectively a particular circuit can be produced self-induced EMF when the current changes. Okay, so this is the inductance. Inductor. So an inductor is a component that exhibits the property of inductance, usually a coil or solenoid. If that inductor's internal electrical resistance is zero, then it is called an ideal inductor. Okay. In real world applications, there is some resistance, but for convenience in calculations, we assume sometimes ideal conditions. It's a common misconception that an inductor prevents current from flowing, but that's not the case. Okay, an inductor does not oppose steady or constant current flow. In an ideal case, constant current passes easily due to zero resistance. Okay, and the inductor's real job is to oppose changes in current, growth or decay. When the current starts to increase, the inductor opposes its increase. When the current starts to decrease, the inductor opposes its decrease. Okay, next is self inductance. So let's understand how many magnetic lines of force, that is magnetic flux phi b, are created in a coil when current flows through it. The fundamental concept of self induction is that when current I flows in a coil, magnetic flux phi b is formed in it. Okay, and this flux is directly proportional to the current. So mathematically, it is written as n phi b is directly proportional to I. So here n means number of turns and n phi b is the total magnetic flux linkage. So to change this proportionality sign into an equality, we use a constant which is called L. So n phi b equal to Li, where constant of proportionality L is called self inductance of the coil. So from Faraday's law, we know Faraday's law states that if this magnetic flux changes with time, then EMF is induced, and its general formula is E equal to minus d n phi b upon dt. Okay, so when we substitute the first equation n phi b equal to Li into this, assuming that L is constant, the final formula becomes E equal to minus L di upon dt. Okay, this equation is very important. Okay, so in this, the negative sign indicates Lenz's law, which confirms that this induced EMF always opposes the change in current due to which it was produced. The SI unit used for measuring self inductance L is Henry, symbol H. Okay, so defining Henry is simple. Let's see. So when there is a rate of change of current of 1 ampere per second and an EMF of 1 volt is induced due to it, then that inductance is called 1 Henry. Okay, and this unit tells us how strongly an inductor will resist a change in a current. Magnetic potential energy of an inductor. So when we build up current I in a circuit, that is raise it from 0 to a steady value, this process does not occur instantaneously. Okay, as the current increases, a back EMF is induced due to self inductance which opposes this increase. Now we will talk about the work done. So to make the current flow against the back EMF, the source, that is battery, has to do work. Okay, and this work is done to establish the current to its final steady value I. The formula to calculate this work done, W is equal to 1 by 2 Li square. This means that uh, the greater the inductance L and the greater the current I, the more work will have to done. Okay, the work that the source has done is not wasted. This work gets stored in the form of magnetic field. Therefore, we call this stored energy magnetic potential energy U. Okay, and the formula for this energy is also similar to the formula for work done. So U equal to 1 by 2 Li square. So when a steady current flows in an inductor, it stores that energy in its magnetic field. So when you switch off the current energy will be released back into the circuit. Okay, formula for self inductance. These different formulas shows how the self inductance L of a coil depends on its physical properties. In all formulas, mu naught means uh, permeability of free space, which is a constant value. Okay, circular coil, for a circular coil with radius r and total number of turns n, the formula for self inductance is L equal to 1 by 2 mu naught pi n square r. Okay, and it is clear from this formula that inductance is directly proportional to square of the number of turns. Okay, and radius r of the coil. This means that if you double the turns, the inductance will becomes 4 times. Okay, and for a solenoid coil having length L, total number of turns n and cross sectional area A. Okay, so to calculate its inductance, we use the formula L equal to mu naught n square A upon L, which is equal to mu naught n square AL. Okay, here A is the cross sectional area of the solenoid L. Okay, solenoid, and L is the its length, and n is the total number of turns. This formula shows that inductance is proportional to the area and the square of the turns and inversely proportional to the length. Okay, there is also an alternate form of this formula in which n number of turns per unit length. Okay, that is n by L. So L equal to mu naught n square AL. Next is toroid. So what is toroid? A toroid is a ring shaped like a donut coil. Its inductance formula is L equal to 1 by 2 mu naught n square into r. Here r is the radius of the toroid, okay, and n is the number of turns. You can see that its formula is quite similar to the formula for a circular coil. Here also inductance depends on n square and radius r. So for a square shaped coil with each side of length a and total number of turns n, the formula for its self inductance is L equal to 2 root 2 divided by pi mu naught n square a. Even in this case, inductance depends on the square of the number of turns and the side length a, okay, of the square. All right. Next is mutual inductance, where in self inductance an EMF was induced in the same coil when the current changed. The situation is a bit different in mutual induction. Okay, here there are two coils which are placed in each other's neighborhood close by. Let's understand the phenomena firstly in simple way. So mutual inductance is the phenomena in which if we change the current in one coil, that is primary coil, then due to change in that current, an EMF voltage is induced in a other coil, that is secondary coil. Okay, and how it works? A changing current in the primary coil creates a changing magnetic field around it. Okay, since the secondary coil is close to it, some part of the that changing magnetic field also linked with the secondary coil. Magnetic flux is linked. Okay, so according to Faraday's law, this changing magnetic flux induces an EMF in the secondary coil. All right, so this is the phenomena of mutual induction. Clear? Yes or no? Anyone? You have doubt? All right. Next is mutual inductance. So let's understand the mutual inductance of coaxial solenoids. We have two coaxial solenoids, inner solenoid S1, radius R1, length L, total turns N1, turn density N1 equal to N1 upon L, capital N1 upon L. Okay. So look at here, uh, the figure. Here, outer solenoid S2, radius R2, length L, total turns N2, and turn density N2, small n2 equal to capital N2 upon small l. Okay, so as you can see in the figure, uh, our assumption is solenoids are very long. Okay, so the magnetic field inside remains uniform and zero at the ends. All right. So, listen carefully. When current I2 flows in the outer solenoid S2, a magnetic field is produced due to it. This field passes through the inner solenoid S1. Okay. So the flux linked per turn with S1 is denoted by phi 1. Since S1 has a total of capital N1 turns, the total flux linkage is capital N1 phi 1. Okay. So according to definition uh, of the mutual induction, the total flux linkage is directly proportional to the current I2 flowing in S2. So mathematically we can understand it. So the formula for this relation is N1 phi 1 equal to M12 I2. The constant M12 in this equation is called the mutual inductance of solenoid S1 with respect to solenoid S2. This constant is a measure of how effectively both coils are magnetically coupled. Okay, it is also known as the coefficient of mutual induction. Its SI unit is Henry. All right, where N1L is the total number of turns in solenoid S1. So in terms of physical dimensions, the final formula for mutual inductions M12 is equal to mu naught N1 N2 pi R1 square into L. Okay, and when current I2 flows in the outer solenoid S2, a magnetic field is produced due to it. So we assume this magnetic field to be uniform inside the solenoid. Okay, so its formula is B2 equal to mu naught N2 I2. Look at here, this one. Here B2 is the magnetic field, mu naught is the permeability of free space, N2 is the number turn density of S2. Okay, and I2 is the current. So this field exists inside both S1 and S2. Now students, we will calculate the total flux linkage in the inner solenoid S1 due to this magnetic field. Okay, linkage means what? The total magnetic flux that passes through all the turns of S1. Okay, so for this we multiply the magnetic field B2 by the area of the inner solenoid and then multiply by the total turns N1. Okay, since the magnetic field is confined to the inner radius, we use the area of the inner solenoid, which is pi r1 square. So by combining this calculation, we derive the formula for N1 phi 1 equal to N1 L into pi R1 square mu naught N2 I2. Clear? Here N1 capital N1 equal to small n1 L is the total number of turns in S1. So upon simplifying this equation, this formula indicates that the total magnetic flux linked with S1 depends on the current I2 in S2. Okay, any doubt? All right. Now we consider the reverse situation. Okay, when current I1 flows in the inner solenoid S1. Okay, a magnetic field is produced due to it, and this magnetic field reaches the outer solenoid S2, and due to this magnetic flux is also linked with S2. Okay, so we describe this flux linkage using this formula, and the formula is N2 phi 2 equal to M21 I1. Here N2 phi 2 is the total flux linkage with S2 and I1 is the current of S1. The constant M21 in this formula is called the mutual inductance of solenoid S2 with respect to solenoid S1. So in this derivation, uh, we assume that the magnetic field inside S1 is solely confined within it. Okay, since S2 completely covers S1, all the S1 magnetic field also passes through S2. So for the calculation, we multiply the total number of turns S2, uh, okay, by the area of S1 and its magnetic field mu1 mu naught n1 I1. So upon performing the derivation, we obtain the expression for the total flux. That is N2 phi 2 equal to N2L into pi R1 square mu naught N1 I1. Alright, where N2L is the total number of turns of S2. By comparing this equation with N2 phi 2 equal to M21 I1, we get the formula for final inductance, final mutual inductance. Okay. So that is M21 equal to mu naught N1 N2 pi R1 square into L. And this formula is similar to the formula for M12, which indicates the mutual inductance is a property between the two coils and does not depend on which the coil current is in. Okay. Any doubt? Now, formula for mutual inductance. So when we have two concentric circular coils, okay, one small and one large with the same center, and we assume the coupling coefficient K to be one perfect coupling in free space or air, okay, then the formula for their mutual inductance M is mu naught N1 N2 pi R1 square divided by 2 R2, where R1 equal to radius of the coil of small radius and R2 equal to radius of the coil for large radius. Okay, and this formula states that M is directly proportional to the area of the small coil. Okay, and inversely proportional to the radius of the large coil. If two solenoid coils are bound one over the other coaxial setup, all right, then their mutual inductance formula simplifies. M equal to mu naught N1 N2 into A divided by L. Here A is a common cross-sectional area, L is the length, N1 N2 are the total turns. So this formula is very common for practical applications such as in transformers. Okay. So in physics, there is an important principle called the theorem of reciprocity. According to this theorem, for a given pair of coils, the value of mutual inductance remains the same whether the current is in the primary coil or in the secondary coil. This means M12 is always uh, equal to M21 and we simply denote this common value by M. So M12 equal to M21 equal to M. Okay. This property indicates that mutual inductance is a fixed physical characteristics of the system independent of the direction or source of the current. Alright. Now we will discuss combination of inductors. Now when two coils which have self inductance L1 and L2 are connected in series, okay, but are placed very far from each other, then their mutual inductance M is 0. Okay, so in this situation the equivalent inductance Ls is simply the sum of their individual inductances, and this is similar to how resistors add up in series. Okay, so Ls equal to L1 plus L2. Here there is no mutual effect, therefore the total inductance is only the sum of individual inductances. If the same coil are placed close to each other, their magnetic fields affect each other. Okay, consequently mutual inductance also needs to be considered. So the formula for equivalent inductance is Ls equal to L1 plus L2 plus minus 2M. So here a plus minus sign means what? Plus 2M is used when current flows in the same sense in both coils, series adding. Okay, this causes magnetic fields to add up and the total inductance increases. Whereas minus 2M is used when the current flows in opposite sense, series opposing. Okay, so this causes magnetic fields to uh, cancel out and total inductance decreases. Now, if when two coils of self inductance L1 and L2 are connected in parallel, then their equivalent inductance LP formula is similar to that of resistors in parallel. So in this case, this formula applies when the coils are far apart from each other. Negligible mutual inductance. Okay. So equivalent inductance is defined as 1 upon LP equal to 1 upon L1 plus 1 upon L2. By solving this equation, we can derive the final formula for equivalent inductance LP equal to L1 L2 divided by L1 plus L2. This formula indicates that the total inductance in parallel is less than the individual inductances. Okay. Now we will talk about the eddy currents. What is eddy currents? Whenever there is a change in magnetic flux associated with a conductor, such as a metal block or plate, induced current are generated throughout. Okay, the entire volume of that conductor, these currents, these flows in circular loops and are called eddy currents. So these currents operating on the principle of Lenz's law oppose the movement or change that produced them. Okay, so imagine just as eddies form in water, similarly current loops form in the conductor. All right. So eddy currents are actual electric currents that flow in the material of conductor. All right, material of conductor, because every material has some intrinsic resistance. These currents cause energy loss when they flow, and this lost energy primarily dissipates in the form of heat. Okay, so this energy loss is unwanted in transformers and motors where it reduces, okay, efficiency. Therefore, engineers use methods to minimize these currents, such as making laminated cores. All right. So let's summarize. So we learned electromagnetic induction, then magnetic flux, then Faraday's law of electromagnetic induction, then Lenz's law, then motional EMF in a loop, then rotational EMF, then self inductance, then magnetic potential energy of an inductor, then formula for self inductance, then mutual induction, then mutual inductance, then formula for mutual inductance, then combination of inductors, then eddy currents. Okay, thank you for your attention. Now students, we will solve some practice questions based on these topics. Okay, so are you ready for practice questions? Yes or no? Hello students. Now we will solve some practice questions based on electromagnetic induction. Okay, this is our disclaimer. So here we will solve some practice questions based on electromagnetic induction. So first question, the magnetic field in a certain region is given by B equal to 40 I cap minus 18 K cap Gauss. Listen carefully, the unit is Gauss here. Okay. How much flux passes through a loop of area 5 centimeters square in this region if the loop lies flat on the xy plane? Okay. So we need to find out how much magnetic flux is passing through this loop. Alright. So given options, option A minus 900 into 10 to the power minus 9 Weber. Option B 900 into 10 to the power minus 9 Weber. Option C 0 and option D 9 Weber. So which one is correct? Think about it and try to solve this question, everyone. You have a some time. Please solve. Which one is correct? Yes. Tell me the correct answer. B, C or D? A. So the correct option is will be A. Okay. So the loop is flat on the xy plane. Okay, which means that its area vector, which is perpendicular to the loop, will be in the direction of z axis. Yes or no? As shown in the figure. Look at here, this one. Therefore, we can represent the area vector as a vector equal to a. We can say a vector equal to a cap. Okay, look at here. And the magnetic field B equal to 40 I cap minus 18 K cap Gauss. This is given. So here to convert firstly, so 1 Gauss equal to 10 to the power minus 4 Tesla. Okay. So we can say the given magnetic field 40 I cap minus 10 to the minus 18 K cap into 10 to the power minus 4 Tesla. Okay. And area is given, that is 5 into 10 to the power minus 4 meter square K cap. Okay. So now we will calculate the magnetic flux. We know the formula phi equal to B dot A. So we know the value of B and we know the value of A. So just substitute the value and take the dot product. You will be get this one. Okay. So when we solving the dot product, you will be get the value of phi. Phi equal to this one minus 90 into 10 to the power minus 8. It means we can say phi equal to minus 900 into 10 to the power minus 9. Okay. So or we can write phi B, or means a magnetic flux minus 900 nano Weber. Clear? So A option is correct. Next question. The flux linked with a coil at any instant t is given by phi equal to 10t square minus 50t plus 250. The induced EMF at t equal to 3 second is what? So you have given the relation for the magnetic flux phi linked with the coil as a function of time. Okay. You need to find the value of induced EMF when the time t equal to 3 seconds. Given options, option A 190 volt, option B minus 10 volt, option C 10 volt and option D 190 volt. So which option is correct? A, B, C or D? Think about it and please try to solve this question, everyone. You have some time. Please solve. Which one is correct? A, B, C or D? So the correct option is option B. So the relation for the magnetic flux phi linked with the coil with time t is given pi equal to 10t square minus 50t plus 250. Okay. So according to Faraday's law of electromagnetic induction, whenever the magnetic flux passing through a coil changes, an induced EMF is generated in that coil. Okay. So the value of this induced EMF is equal to the negative of the rate of change of flux. So its formula is E equal to minus d phi b upon dt, where d phi upon dt means differentiation, that is the rate of change of flux. So we will differentiate the flux equation with respect to time. So it will be E equal to minus differentiation of 10t square minus 50t plus 250, okay, with respect to time. So when we differentiate it, you will be get E equal to minus 10 into 2t minus 50, and you know the value of t, that is 3 seconds. So just substitute the value of t and you will be get the E. So E equal to 10 into 2 into 3 minus 50. So when we solving or performing the calculations, you will be get minus 10 volt. Okay, and the negative sign means that the direction of this EMF opposes the change in flux. Okay, next question. A coil having N turns and resistance R omega is connected with a galvanometer of resistance 4 R omega. This combination is moved for time t seconds from a magnetic field W1 Weber to W2 Weber. Okay, so the induced current in the circuit is what? So here the question asked is how much induced current will flow in this closed circuit due to this flux change. So given options, option A W2 minus W1 divided by 5 R NT. Option B minus N W2 minus W1 divided by 5 RT. Option C minus N2 minus N2 minus W1 divided by RNT. And option D minus N W2 minus W1 divided by RT. So which option is correct? A, B, C or D? Please solve this question everyone. You have some time. And tell me the correct one. Here R omega is connected in series with a galvanometer. Okay. Please solve. Which one is correct? So the correct option will be B. Okay. So according to question, a coil and a galvanometer are connected in series with each other. Okay. So in a series connection, the total resistance is the sum of the resistances of the components. So for series connection, the total resistance is equal to resistance of coil plus resistance of galvanometer, and we know the resistance of coil and we know the resistance of galvanometer. So resistance of coil R plus resistance of galvanometer, that is 4R. So when we adding these, you will be get R total equal to 5R omega. Okay, and we know the Faraday's law. The rate of change of flux of an we can say induced EMF induced in the coil is equal to minus N into d phi upon dt, where d phi upon dt is the rate of change of magnetic flux. So induced current is equal to E upon R equivalent. Okay, so just substitute the value of E, that is minus d phi upon dt. So you will be get minus N upon R equivalent into d phi upon dt. Let this is equation first. So here d phi is equal to W2 minus W1 and dt equal to T. Okay, we know W1 and W2 are the flux associated with one turn and second turn. So putting the given values in this equation first, we get I equal to minus N upon 5R into W2 minus W1 divided by T. Okay, so this is our answer. All right, next question. In a coil of resistance 100 ohm, a current is induced by changing the magnetic flux through it, as shown in the figure. The magnitude of the change in flux through the coil is what? In this question, we are given a coil whose resistance R is 100 ohm. The variation of the induced current in the coil with the time is shown in the graph. Okay, so we a question asked for the magnitude of the change in flux. This question asked in JEE Main 2017. Okay, so based on this graph, you have to find out the answer. Given options: option A, 225 Weber, option B, 250 Weber, and option C, 275 Weber, and option D, 200 Weber. Okay, so please find out the correct answer. You have some time. Which one is correct? Yes. Varsha, Karthik, anyone? Please solve this question. Okay, so to solve this question, you need to remember the maximum current, that is 10 here, and the maximum time 0.5. Okay, so firstly, you need this, and then during solving this question, you need to these terms. All right, please solve. Which one is correct? A option, B option, or C option, or D option? Magnitude of change in flux, you have to find out the, okay. All right, please solve. Current measured in ampere and time in second. Okay, in y-axis current and x-axis time. Clear? Yes or no? Let's see the correct option. So correct option for this will be option B. We know that induced current, that is I equal to E upon R. Okay, what is E here? Is the induced EMF. So according to Faraday's law of induction, whenever the magnetic flux passing through coil changes, an induced electromotive force is produced in it. Okay, and its formula is equal to d phi upon dt. So we know I equal to E upon R. So just substitute the value of E, that is d phi upon dt. So you will be get I equal to d phi upon dt into 1 by R. Okay. So on cross multiplying, uh, the term obtained d phi is equal to I R dt. Okay. So to find the change, integration is performed when both sides are integrated. Okay. So phi, when we integrate LHS side d phi, you will be get phi. Now we will integrate IR dt. Here R is constant. So we will keep the constant term outside the integration. Okay. So phi will be R into d phi upon R into integration I dt. Okay. Here I dt means what? I dt means uh, area under the current versus time graph. So this term will be integrate. So you have to find out the integration. Uh, it means you have to find out the area under the current versus time graph. Okay. So we can say I dt equal to area under it time graph. And we know the graph is in the shape of triangle. Yes or no? So the formula for the area of triangle will be I dt equal to 1 by 2 into 10 into 0.5. We know height, base into height. So base 1 by 2, base is 10 and height is 0.5. Yes or no? No. Base is maximum current and maximum time. Maximum current 10 and time 0.5 second. So when we performing calculation, you will be get integration of I dt equal to 2.5. This is not integration. This is direct. We calculated it from the area under IT graph, and area under IT graph is what? Area of triangle, because the shape having triangle shape. So when we solving this calculation, you will be get uh, phi equal to R into 2.5. So we know the value of R, that is 100. So you will be get 100 into 2.5. So phi equal to 250 Weber. Okay, clear? So this is our current answer. Any doubt? Clear. Okay. Next question. A cylindrical bar magnet is rotated about its axis. A wire is connected from the axis and is made to touch the cylindrical surface through a contact. Okay. Then which option is correct? Option A, as direct current flows in the ammeter A. Option B, no current flows through the ammeter A. Option C, an alternating sinusoidal current flows through the ammeter A with a time period T is equal to pi upon omega. Okay. And option D, a time varying non sinusoidal current flows through the ammeter A. Okay. So here you have to find out the correct option. You have some time to solve this. After that, we will provide the solution of this question. Okay. Please solve. Which one is correct? Which one is correct? So correct option will be option B. All right. Let's see the solution. So according to question, a cylindrical, look at here, a cylindrical bar magnet is placed near a current, near a circuit, okay, containing an ammeter A. Okay, this one, ammeter A. while being rotated on its axis. The figure shows a cylindrical bar magnet with its north and south poles at the opposite ends along its axis. So north pole and south pole. Okay, the magnet is rotating about this central axis, indicated by the angular velocity omega. Okay, so central axis like this rotation, and angular velocity omega. Okay, and a wire, listen carefully, a wire is connected from the axis of the magnet and extends outward to touch the cylindrical surface of the magnet through a contact point. And this wire is part of a circuit that includes an ammeter A, which is used to detect any current flowing in the circuit. And this setup is designed to check whether rotating magnet about its own axis uh, induces any current through electromagnetic induction. Okay, so according to Faraday's law of electromagnetic induction, current is induced in a circuit only when there is a change in magnetic flux linked with it. Alright, so magnetic flux phi means how many magnetic field lines are passing through a given area. So when a cylindrical bar magnet rotates around its axis, the magnetic field lines remains symmetrical and their position relative to wire and circuit does not change. Alright, therefore the magnetic flux phi linked with the circuit remains constant. Clear? Since there is a no change in magnetic flux, so d phi upon dt should be 0. So no electromotive force is induced in the circuit. Why? Because we know the formula E equal to minus d phi upon dt. If d phi upon dt is equal to 0, okay, it means what? It means no electromotive force is induced in the circuit. So as a result, no current flows through the ammeter. Okay, it means what? The value of I is what? 0. No current flows through the ammeter. All right, so which option is correct? B option. Clear everyone? Any doubt? All right, that's all for the today. Thank you for your attention. In next lecture we will learn about the alternating current. All right, thank you for your attention.